right, this is CS50's Introduction to Programming with Python. My name is David Malin, and over these past many weeks have we focused on functions and variables early on, then conditionals and loops and exceptions, a bit of libraries, unit tests, file I/O, regular expressions, object-oriented programming, and really, etc. And indeed, that's where we focus today, is on all the more that you can do with Python and programming more generally beyond some of those fundamental concepts as well. In fact, if you start to flip through the documentation for Python in all of its form, all of which is, as always, accessible at docs.python.org, you'll see additional documentation on Python's own tutorial and library, its reference, its how-to. And among all of those various documents, as well as others more online, you'll see that there's some tidbits that we didn't quite touch on. And indeed, even though we themed these past several weeks around fairly broad topics that are rather essential for doing typical types of problems in Python, it turns out there's quite a number of other features as well that we didn't necessarily touch on, that didn't necessarily fit within any of those overarching concepts, or might have been a little too much too soon if we did them too early on in the course. And so in today, our final lecture, will we focus really on all the more that you can do with Python and hopefully whet your appetite for teaching yourself all the more too. For instance, among Python's various data types, there's this other one that we haven't had occasion to yet use, namely a set. In mathematics, a set is typically a collection of values wherein there are no duplicates. So it's not quite a list. It's a bit more special than that, in that somehow any duplicates are eliminated for you. Well, it turns out within Python, this is an actual data type that you yourself can use in your code. And via the documentation here, might you be able to glean that it's a useful problem if you want to somehow automatically filter out duplicates. So let me go ahead and go over to VS Code here, and let me go ahead and show you a file that I created a bit of in advance, whereby we have a file here called houses.py. And in houses.py, I already went ahead and whipped up a big list of students, inside of which is a number of dictionaries, each of which represents a student's name and house, respectively. Now, this is a pretty sizable dictionary, and so it lends itself to iteration over the same. And suppose that the goal here was quite simply to figure out, well, what are the unique houses at Hogwarts in the world of Harry Potter? It would be nice, perhaps, to not have to know these kinds of details or look them up online. Here we have a set of students, albeit not exhaustive with all of the houses, but among these students here, what are the unique houses in which they live? Well, I could certainly, as a human, just eyeball this and tell you that it's, well, Gryffindor, Slytherin, Ravenclaw, but how could we go about doing it programmatically for these students as well? Well, let's take one approach first here. Let me go into houses.py, and let me propose that we first, how about create an empty list called houses, in which I'm going to accumulate each of the houses uniquely. So every time I iterate through this list of dictionaries, I'm only going to add a house to this list if I haven't seen it before. So how do I express that? Well, let me iterate over all of the students with for student in students, as we've done in the past. And let me ask you a question now. So if the current student's house, and notice that I'm indexing into the current student because I know they are a dictionary or dict object, and if that student's house is not in my houses list, then, indented, am I going to say houses dot append, because again, houses is a list, and I'm going to append that particular house to the list. Then at the very bottom here, let me go ahead and do something somewhat interesting here and say for each of the houses that I've accumulated in, I could just say houses, but if I just say houses, what was the point of accumulating them all at once? I could just do this whole thing in a loop. Let's at least go about and sort those houses with sorted, which is going to sort the strings alphabetically. And let's go ahead therein and print each of the houses. Let me go ahead now in my terminal window and run Python of houses.py and hit enter. And there we have it. Gryffindor, Ravenclaw, Slytherin in alphabetical order, even though in the list of dictionaries up here, technically, the order in which we saw these was Gryffindor, 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 Slytherin, Ravenclaw. So indeed, my code seems to have sorted them properly. So this is perfectly fine, and it's one way of solving this problem. But it turns out we could use more that's built into the language, Python, to solve this problem ourselves. Here I'm rather reinventing a wheel, really the notion of a set wherein duplicates are eliminated for me. So let me go ahead and clear my terminal window and perhaps change the type of object I'm using here. Instead of a list, which could also be written like this to create an empty list, let me go ahead and create an empty set, whereby I call a function called set that's going to return to me some object in Python that represents this notion of a set wherein duplicates are automatically eliminated. And now I can tighten up my code because I don't have to use this if condition myself. I think I can just do something like this. Inside of my loop, let me do houses.add. So it's not append for a set. It's append for a list, but it's add to a set per the documentation. Then let me go ahead and add this current student's house. And now I think the rest of my code can be the same. I'm just now trusting, per the documentation for set in Python, that it's going to filter out duplicates for me. And I can just blindly add all of these houses to the set. And any duplicates already there will be gone. Python of houses.py and enter. And voila, we're back in business with just those three there as well. Let me pause here to see if there's any questions now on this use of set, which is just another data type that's available to you, another class in the world of Python that you can reach for when solving some problem like this.
How can we locate an item in a set? For example, find Gryffindor in that set.
How do you find an item in a set? You can use very similar syntax as we've done for a list before. You can use syntax like if Gryffindor in houses, then, and you can answer a question along those lines. So you can use in and not in and similar functions as well. Other questions on set?
Okay, what happens if you have a similar house name? Let's say instead of Slytherin, it is maybe an O instead of an I. Will the for loop throughout each of those letters in the house name?
It would compare the strings. So if Slytherin appears more than once but is slightly misspelled or miscapitalized, if I heard you right, those would appear to be distinct strings. So you would get both versions of Slytherin in the result. However, we've seen in the past how we can clean up users' data if indeed it might be messy. We could force everything to uppercase or everything to lowercase, or we could use capitalize, the function built into stirs, or title case that would handle some of the cleanup for us. In this case, because the data is not coming from humans using the input function, I wrote the code in advance, it's safer to assume that I got the houses right. But that's absolutely a risk if it's coming from users. Allow me to turn our attention back to some of the other features here that we can leverage in Python if we dig further into the documentation and read up more on its features. Well, in some language, there's this notion of global variables, whereby you can define a variable that's either local to a function, as we've seen many times, or if you put a variable outside of all of your functions, perhaps near the top of your file, that would generally be considered a global variable. Or in the world of Python, it might be specific to the module, but for all intents and purposes, it's going to behave for a given program as though it is global. However, it turns out that if you do this when solving some problem down the line, whereby you have multiple functions and you do have one or more variables that are outside of those functions, you might not be able to change those variables as easily as you might think. So indeed, let me go back to VS Code here. And in just a moment, I'm going to go ahead and create a new file. How about called bank.py? Let's go ahead and implement the notion of a bank wherein we can store things like money in various forms. And let me go ahead and do this. Let me go ahead and implement a very simple bank that simply keeps track of my total balance, the number of dollars or cents or whatever I might be storing in this bank. And I'm going to give myself a variable called balance at the top, which is an integer, set to 0. Now let me go ahead and define a main function, as we often do. And inside of my main function, let me go ahead and print out, quote unquote, balance, and then print out the value of balance itself, passing to print, as we've often done, more than one argument so that they get separated by a single white space. And now, since I have a main function, really setting the stage for doing more interesting things soon, let me go ahead and do our usual if the name of this file equals underscore underscore main, then go ahead and call main. So this is a terribly short program, but it's perhaps representative of how you might solve some future problem in Python, whereby you have a main function that's going to eventually do some interesting stuff. And at the top of your file, you have one or more variables that are just useful to keep there because then you know where they are. And perhaps not just main, but other functions can access them as well. So let's see, when I run this program, Python of bank.py, I would hope, based on my own intuition thus far, that I'm going to see that my current balance is 0. That is to say, even though the balance variable is defined on line 1, hopefully I can still print it on line 5 inside of main, even though balance was not defined in my main function. Here we go, hitting enter, and voila, balance 0. So it does seem to work. even if you declare a variable in Python outside of your functions, it appears that you can access it. You can read the value of that variable even inside of a function like main. Well, let's get a little more adventurous now, because this program really isn't solving anyone's problems. Let's go ahead and implement more of a bank, like the ability to deposit money into the bank and to withdraw money from the bank, thereby giving me some more functions that might very well need to access that same variable. Let me clear my terminal window here, and let me go ahead and pretend for the moment that I have the ability to deposit, say, $100 or 100 coins, whatever the unit of currency is here. And then maybe I want to withdraw straight away 50 of those same dollars or coins. And now let me go ahead and just print out at the bottom of main what my new balance should be, so that in an ideal world, once I've deposited 100, then withdrawn 50 after starting at 0, I'd like to think that my new balance on line 8 should indeed be 50. All right, but I haven't implemented these functions yet, so let's do that as we've done in the past. Down here, I'm going to go ahead and define another function, deposit. I'm going to say that it takes an argument called n for a number of coins or dollars or the like. And I'm just going to do this. I'm going to go ahead and say balance plus equals n, thereby changing the value of n. I could do it more verbosely, balance equals balance plus n, but I'm going to use the shorter hand notation here instead. And now let's implement withdraw. So define a function called withdraw. It too is going to take a variable, an argument n for number of dollars or coins. And now I'm going to go ahead and subtract from balance using minus equals n as well. And I'm still going to call main if the name of this file is main. So what have I done? I've just added not just one, but 3 functions total, all of which apparently need to access balance by printing it, incrementing it, or decrementing it, as we've seen here. All right, let me go ahead and focus on these 3 functions here. Let me go back to my terminal window and run python of bank.py and hit enter. And wow, seems like we've introduced some number of problems here. And what are these problems? Well, unbound local error is perhaps the first time we've seen this one here. Local variable balance referenced before assignment. And that's a bit misleading, definitely confusing, right? Because I absolutely assigned balance a value on the top of my code. And indeed, if I scroll back up, nothing has changed or been lost up there. It's definitely been assigned a value. And now on line 12, it would seem that when deposit is called, I'm just trying to access that variable again. So intuitively, what might explain this error message? Unbound local error. What is Python telling us there that Python can or can't do when it comes to these so-called global variables that are at the top of my file?
So if you want to change this variable, you should write inside the function main. And the global variable unchangeable.
Yeah, so if you want to change the value, it might need to be local to the function. If you are trying to change a global variable, though, in a function, it clearly does not work. So it's OK to read a global variable, read meaning access it and print it and so forth. But apparently, you can't write to a global variable in the same way from within one of these functions. All right, well, maybe the fix is to do this. Let me clear my terminal window in that error. And maybe I could just do this. Let's get rid of the global variable. And let's go ahead and put it, for instance, inside of main. Might this now work? Well, let me try this now. Python of bank.py enter. That alone did not solve it. I still have an unbound local error. This time, though, it's for a different reason. It turns out now that balance on line 2 is by definition a local variable. A local variable is one that exists in the context of a function, at least in this case. A global variable is the opposite, one that does not, for instance, at the top of my file. So here is another distinction in Python. If you declare a variable in a function like main, just as I've done on line 2 with balance, it is indeed local to that function. Deposit and withdraw do not have access to that same variable. Why? Because it's local to main. And so you would think now we're kind of stuck in this vicious cycle. Well, maybe the solution then is to move balance globally so all 3 functions can access it. But clearly where we began, as Elena noted, we can't therefore change it. So it turns out the solution to this problem in Python is ironically exactly this keyword here. It's a little different, as you might have seen if you programmed before in other languages, but there's indeed a keyword in Python called global that allows you to tell a function that, hey, this is not a variable that's local to you. I mean it to be a global variable that I want you to edit. So if I go back to VS Code here, clearing my terminal window to get rid of that error, let me go ahead and undo the change I just made and put balance back at the top of my file. But this time what I'm going to do is I'm going to inform my two functions that need to change the value of balance, that it is indeed global by typing global balance. Again, here as well as here, global balance. I still leave the same lines of code now on lines 13 and 18 that increment and decrement balance, but this now use of keyword global is a little bit of a clue to Python that, oh, OK, it's not a local variable. This is not a bug that you've introduced. You mean for me to edit this variable up above. So now let me go ahead in my terminal window and run Python of bank.py. I'm hoping to see that my balance is 0 plus 100 minus 50 is 50. And indeed, it now is. It starts off at 0 per my first print statement on line 5, but it ends up at 50 total at below that on line 8. Let me pause here to see if now there's any questions on these global or local variables.
What happens when you declare a variable globally and as in the same variable globally and in a function?
A good question. You're always thinking about the so-called corner cases. So if you declare a variable both globally, like at the top of your file, and then an identically named variable inside of a function, same name, the latter will shadow, so to speak, the former. That is, you'll be able to use the latter, that is the local variable, but it will have no effect on the global variable. Temporarily, Python will only know that the local variable exists. So in general, the rule of thumb is just don't do that. Not only might it create bugs in your code because you don't quite change what you intend to change, it's also perhaps non-obvious to other readers as well. Other questions on globals or locals?
OK, what if we decide to add balance as an argument inside the main function?
Yeah, another good instinct, but in this case, that also is not going to solve the problem, because if you pass in a variable like balance to each of the functions and then change it within that function, it's only going to be changing, in effect, a local copy thereof. It's not going to be changing what's outside of those functions. So I think we actually need a better way altogether, and in fact, allow me to transition to perhaps a modification of this same program. Recall that we looked most recently at this notion of object-oriented programming, whereby you can model real-world entities, for instance, a bank, and you can model and encapsulate information about that real-world entity, for instance, like someone's account balance. So let me propose that we actually do this. Let me start from scratch with bank.py, get rid of the global variable altogether, and actually use some object-oriented code. Let me define a class called account to represent someone's bank account, and then let me go ahead and initialize with my init method, which again takes by convention at least one argument called self. Let me go ahead and initialize every person's bank account to some value like 0. Now, how can I do that? Well, I'm going to go ahead and do self.balance equals 0, thereby giving me an instance variable called balance initialized for this account to 0. But I'm going to proactively remember how we also introduced this notion of properties, which might otherwise collide with the names of my instance variables. So just by convention, I'm going to do this. I'm going to rename this instance variable proactively to underscore balance to effectively indicate that it's private, even though that's not enforced by Python. It's just a visual clue to myself that this is something that really I should not, or other code should not touch, just functions in this class. Now let me go ahead and do this. Let me go ahead and define an actual function called balance that really is going to be a property whose purpose in life is just to return self.balance. And I'm going to go explicitly and say this is indeed a property of this class. Now let me go ahead and re-implement those other two functions, deposit and withdraw, but in the confines of this class. So I'm going to say define deposit. It's going to take in an argument self as always, but an additional one, n, a number of dollars or coins to deposit. And how do I now manipulate this? Well, I'm going to do self.underscore balance plus equals n. And now down here, I'm going to do def withdraw self n, just like for deposit. But here, I'm going to do self.balance minus equals n. And now, if I go down below this class, I'm going to go ahead and define myself a main function, just so I can try this now out. I'm going to go ahead and create an account object, by calling the account constructor. That is the name of the class with 2 parentheses. If I'm not passing in any arguments to init, I'm going to go ahead now and print out, as before, the balance of my account. But to do that, I'm going to access the property of that account like this. And I'm going to go ahead now and say deposit another $100 or coins with deposit 100. And I'm going to go ahead like before and also now immediately withdraw, for whatever reason, 50 of the same. And now I'm going to print one last time balance, followed by account.balance, again accessing that property. And for this whole thing to work, of course, I need one of these if name equals underscore main. Then go ahead and call main. Now, before I run this, you'll see that it rather escalated quickly. I had a very simple goal at hand to implement the notion of a bank, and I was able to implement that perfectly fine ultimately by declaring balance to be global, but then to tell each of my functions that it is indeed global. But that's not really the best form of encapsulation we have at our disposal now, right? Per our focus on object-oriented programming, if we're trying to implement some real-world entity like an account at a bank, that's what classes allow us to do. And it allows us to solve that same problem perhaps a little more cleanly, certainly if we're going to accumulate more and more functions or methods over time. So if I didn't make any mistakes here, if I run python of bank.py and hit enter now, you'll see that it just works just fine. Because in the world of classes in Python, these so-called instance variables are by definition accessible to all of the methods in that class because we're accessing them all by way of that special parameter self. So which way to do it? For a reasonably small script wherein you are simply trying to implement a script that has some global information, like an account balance that you then need to manipulate elsewhere, the global keyword is a solution to that problem. But generally speaking, in many languages, Python to some extent among them, using global variables tends to be frowned upon only because things can get messy quickly. And it can become less obvious quickly exactly where your information is stored, if some of it's up here, some of it's in your function. So generally, the rule of thumb is to use global variables sparingly. Though technically speaking in Python, these global variables are technically local to our module if we were indeed implementing a library and not just a program. So in short, try to use global variables sparingly, but when you do, there is a solution to these same problems. Questions now on globals or our re-implementation of the same idea, but using full-fledged object-oriented programming?
I just would like to ask what this property does.
What this property does. So if I go back to VS Code here, you'll see that this was a technique we looked at in our lecture on object-oriented programming, whereby a property is a instance variable that's somehow protected. It allows me to control how it can be read and written. So in this case, I only have what's called generally a setter. In this case, I only have what's generally called a getter. And there's no mention of the word getter here. This is just what @property means. That function balance will allow me, recall, to use syntax like this, where I can pretend as though balance is indeed, with no underscore, an instance variable. But I can now prevent code like mine in main from trying to change balance. Because I do not have a setter, I would not be able to do something like account balance equals 1,000 to just give myself $1,000 or coins because I have not defined a setter. So again, per our focus on object-oriented programming, these properties just allow me some finer grained control. Some languages allow you to define variables that are, so to speak, constant. That is, once you have set a value to them, you cannot change the value of that variable. And that tends to be a good thing because it allows you to program defensively. Just in case you accidentally or someone else accidentally tries to modify the value of that variable, if you have declared it in some language as a constant, it cannot be changed, or usually cannot be changed without great effort. Unfortunately, in Python, we're again on the sort of honor system here, where we have conventions to indicate that something should be treated as though it's constant, but that's not actually enforced by the language. So for instance, let me go back here to VS Code, and let me create a new file, for instance, called meows.py. And let's see if we can't implement the notion of a cat meowing on the screen. So I'll do code of meows.py. And in meows.py, let me go ahead, for instance, and implement a very simple program that just has a cat meowing 3 times. So how about this? For I in the range of 3, go ahead and print out quote unquote meow. All right, well, we've seen in the past how we can clean this up a little bit. For instance, if I'm not actually using I might as well Pythonically just change the name of that variable to underscore, even though that has no functional effect here. But here we have this 3 sort of randomly hard-coded, that is typed explicitly into my code. And it's totally not a big deal when your code is only 2 lines. But imagine that this is a much bigger program with dozens or even hundreds of lines. And imagine that one of those lines just has a 3 in there somewhere. Like, you're never going to find that 3 very easily. And it's going to be very easily overlooked by you or colleagues or others that you've hard-coded some magic value like a 3 right there in your code. So it tends to be best practice, not just in Python, but other languages as well. Anytime you have what is essentially a constant, like a number 3 that shouldn't ever change, is to at least let it bubble up, surface it to the top of your code so that it's just obvious what your code's constant values are. And so by that I mean this. At the top of this file, it would probably be a little clearer to colleagues and frankly me tomorrow after I've forgotten what I did today to define a variable like meows and set it equal to 3. And then instead of hard coding 3 here, or even lower in a much bigger program, let me just go ahead and pass in that variable's value to my loop so that now it's just kind of obvious to me that meows is apparently the number of times to meow. And if I ever want to change it, the only code I have to change is at the very top of my file. I don't need to go fishing around or figure out what's going to break, what do I need to change. I just know that I can change these constants up at the top. The problem, though, with Python is that Python doesn't actually make variables constant. It's indeed a convention in Python and some other languages to at least capitalize your variables when you want to indicate to the world that you should not touch this. It is constant. But there is literally nothing in my code preventing me from saying, you know what, today I feel like 4 meows instead. Like, that would work. In other languages, though, there's typically a keyword or some other mechanism syntactically that would allow you to prevent line 3 currently from executing so that when you tried to run your code, you would actually get an error message explicitly saying you cannot do that. So Python, again, is a bit more on the honor system when it comes to these conventions instead. Now, it turns out there's other types of constants, quote unquote, that Python typically manifests. And in fact, let me go ahead and change this around a little bit. Let me delete this version of meows. And let me introduce, again, a class from our discussion of object-oriented programming, like a class representing a cat, another real-world entity. Recall that within classes, you can have not just instance variables, but class variables. That is, variables inside of the class that aren't inside of self per se, but they're accessible to all of the methods inside of that class. Here, too, there's a convention, but not enforced by Python, of having class constants, whereby inside of the class, you might want to have a variable that should not be changed, but you just want to indicate that visually by capitalizing its name. So for instance, if the default number of meows for a cat is meant to be 3, I can literally, inside of my class, but outside of any of my defined methods, just create a class variable, all capitalized, with that same value. And then if I want to create a method like meow, for instance, which as an instance method might take in self, as we know. And then I might have my loop here for underscore in the range of, and now I need to access this. The convention would be to say cat.meows to make clear that I want the meows variable that's associated with the class called cat. Then I'm going to go ahead and print out one of these meows. And now at the bottom of my code, outside of the class, let me go ahead and do something like this. Let me instantiate a cat using the cat constructor. Notice this is important. Per our discussion of OOP, the class is capitalized by convention, but the variable over here is lowercase. And I could call it just C or anything else, but I kind of like the symmetry of calling it little cat here and big cat, so to speak, over here. And now if I want this particular cat to meow that default number of 3 times, I can just do cat.meow like this. And that method, meow, is going to, per line 5, access that class constant. But again, it's constant only in the sense that you should not touch that, not that it's actually going to be enforced by the language. All right, let me go ahead then and run this with python of meows.py. And there it is, 3 of our meows, meow, meow. It turns out that Python is a dynamically typed language. That is to say, it's not strongly typed, whereby when you want an int, you have to tell the program that you are using an int. You don't have to tell the program that you are using a stir or a float or a set or anything else. Generally speaking, to date, you and I, when we're creating variables, we just give a variable a name. We frequently assign it using in the equal sign some other value. And honestly, Python just kind of dynamically figures out what type of variable it is. If it's quote unquote hello world, the variable is going to be a stir. If it's 50, the integer, the variable is going to be an int. Now, in other languages, including C and C++ and Java and others, it's sometimes necessary for the programmer to specify what types of variables you want something to be. The upside of that is that it helps you detect bugs more readily, because if you intend for a variable to store a string or an integer, but you accidentally store an integer or a string, the opposite, or something else altogether, your language can detect that kind of mistake for you. When you go, for instance, to run the program, it can say, no, you've made a mistake, and you can fix that before your actual users detect as much. In Python 2 here, it's again more of a friendly environment where you can provide hints to Python itself as to what type a variable should be, but the language itself does not strongly enforce these. Rather, you can use a tool that will tell you whether or not you're using a variable correctly, but it's typically a tool you would run as the programmer before you actually release your code to the world. Or if you have some kind of automated process, you can run this kind of tool just like you could reformat or lint your code with some other program before you actually release it to the world. So how might we go about using these so-called type hints? Well, they're documented in the usual place in Python's own documentation. And it turns out there's a program that's pretty popular for checking whether or not your code is adhering to your own type hints. And that program here is called MyPy, and it's just one of several, but this one's particularly popular and can be easily installed in the usual way with pip install MyPy. And its own documentation is at this URL here, but we'll use it quite simply to check whether or not our variables are indeed using the right types. So how can we go about doing this? All right, let me go back here to VS Code, clear my terminal window, and in fact erase meows.py as it currently was, and let's implement a different version of meows that quite simply has a function called meow that does the actual meowing on the screen, and then I'm just going to go ahead and call that function down toward the bottom. I'm not going to bother with a main function just for simplicity so that we can focus, as always, only on what's new. So here we are defining a function called meow. It's going to take a number of times to meow, for instance, n for number. And inside of this function, I'm going to do my usual for underscore in the range of n, go ahead and print quote unquote meow. So based on our earlier code, I think this is correct. I've not bothered defining the variable as I. I'm instead using the underscore because I'm not using it anywhere. But I think I now have a working function whose purpose in life is to meow 0 or 1 or 2 or 3 or more times. Well, let's use this function. Again, not bothering with main. I'm just going to keep my function at the very top because there's only one. And I'm going to write my code here on line 6. So I'm going to ask the user for a number. And I'm going to go ahead and prompt them in the usual way for that number of times to meow. And now I'm going to go ahead and call meow on that number. Now, some of you might see what I've already done wrong, but perhaps I myself don't. So let me go into my terminal window and run Python of meows.py, the goal being to prompt me. This seems to be working. I'm going to type in 3. And I would expect now the meow function to print out meow 3 times. Enter. But no, there's some kind of type error here. Stir object cannot be interpreted as an integer. Why might that be? Why might that be?
Because the input function returns a string instead of an integer.
Exactly. The input function returns a string or a stir, not an int. So in the past, of course, our solution to this problem has just been to convert the string to an int by using the int function. But now let me start programming more defensively so that, honestly, I don't even find myself in this situation at all. Let me go ahead and do this. Let me add what's called a type hint to my function that explicitly specifies for meow what type of variable should be passed in. I'm going to go ahead now and change the very first line of my code in my function to specify that n colon should be an int. And this is a type hint. The fact that I've added a colon, a space, and the word int is not creating another int or anything like that. It's just a hint, an annotation, so to speak, to Python that this variable on the left called n should be an int. Now, unfortunately, Python itself doesn't care because, again, these type hints are not enforced by the language, and that's by design. The language itself in the community prefers that Python be dynamically typed, not so strongly typed as to require these things to be true. But if I run meows.py, type in 3 again, the same error is there. But let me go about trying this MyPy program, an example of a program that understands type hints, and if I run it proactively myself, can find bugs like this in my code before I, or worse, a user, actually runs and encounters something cryptic like this type error here. Let me clear my terminal window, and this time run mypy space meows.py. So I'm going to run mypy on my program, but I'm not running Python itself. When I hit enter, we'll see this. All right, we see now that MyPy found apparently an error on line 7. Error, argument 1 to meow has incompatible type str expected int. So it's still an error message, but MyPy is not a program that my users would use. This is a program that you and I as programmers would use. And because we have run this code now, before we, for instance, released this program to the world, I can now see, even before the code is called or run, oh, I seem to be using my argument to meow wrong. I had better fix this somehow. Well, I can actually go about adding type hints even to my own variables here so as to catch this another way too. If I know on line 6 that I'm creating already a variable called number, and I know already that I'm assigning it equal to the return value of input, I could give MyPy and tools like it another hint and say, you know what, this variable called number should also be an int. That is to say, if I now start getting into the habit of annotating all of my variables and arguments to functions, maybe MyPy can actually help me find things quite quickly as well before I get to the point of running Python itself. Let's go ahead and try this again. MyPy of meows.py and hit enter. And this time, notice that MyPy actually found the mistake a little more quickly. Notice this time it found on line 6 that error, incompatible types in assignment, expression has type str, variable has type int. So before I even got to the point of calling meow, line 6 via this type hint, when used and analyzed by MyPy, has helped me find, oh, wait a minute, I shouldn't be assigning the return value of input to my variable called number in the first place. Why? MyPy has just pointed out to me that 1 returns a str. I'm expecting an int. Let me fix this now instead. All right, so let me clear my terminal window. And now let me do what most of you were probably thinking I should have done in the first place after all of these weeks. But now let me go ahead and convert the return value of input to an integer. For today's purposes, I'm not going to try to catch any exceptions or the like. We're just going to assume that the user types this in properly. And now let me go ahead and run mypy of meows.py, having not only added 2 type hints to my argument, to my function, to my variable down here on line 6, and I've also now fixed the problem itself. Let me go ahead and run mypy, and success. No issues found in one source file. Now it's more reasonable for me to go and run something like Python of meows and just trust that when I type in 3, at least I'm not going to get a type error. That is, I didn't mess up as a programmer with respect to the types of my variables. Why? Because when I wrote the code in the first place, I provided these annotations, these hints that inform tools like MyPy that my intention had better line up with what the actual code does. Let me pause here and see if there's now any questions on type hints or MyPy.
Is it common, or how common is it for those to be used, or is it just that it's more used in more complex code where it's more difficult to ensure that you're actually using the correct type in the way that you're using variables?
It's a good question, and it's rather a matter of opinion. Python was designed to be a little more versatile and flexible when it comes to some of these details, partly for writability, to make it easier and faster to write code, partly for performance, so that the program like Python doesn't have to bother checking these kinds of details. We can just get right into the code. The reality, though, is that strong type checks do tend to be a good thing for the correctness of your code. Why? Because programs like MyPy can find, before your code is even run, if there's already known to be an error, and it tends to be good for defensive programming. So the situation essentially is that within the Python ecosystem, you can annotate your types in this way. You can use tools to use those type hints. But to date, Python itself does not enforce or expect to enforce these conventions. In larger code bases, in professional code bases, commercial code bases, probably, depending on the project manager or depending on the engineering team, they may very well want themselves to be using type hints. Why? If it just decreases the probability of bugs. In fact, let me propose now that I imagine a situation where instead of expecting that meow prints meow, meow, meow some number of times, suppose that I accidentally assume that the meow function just returns meow some number of times. We saw, for instance, when focusing on unit tests, that it tends to be a good thing to have functions that return values, be it an int or a string, rather than just having some side effect, like printing things out themselves. So perhaps I'm still in that mindset, and I've just assumed mistakenly for the moment that meow returns a value like meow or meow meow or meow meow meow, a big string of some number of meows, rather than just printing it itself as it clearly does at the moment on line 3. And therefore, suppose that I accidentally did something like this. Rather than just getting the number and passing it to meow, suppose I did this. Suppose I declared a number of a new variable called meows, the type of which I think should be stir. And suppose, again, I assume accidentally that meow returns to me a string of those meows so that I myself can then print them later. This would be a little more conducive, arguably, to testing my meow function. Why? Because I could expect that it's returning meow or meow meow or meow 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 separated by new lines, returning a stir that I could then assert equals what I expect it to be in something like a unit test. I'm not going to bother writing any unit test now, but let's just suppose that's the mindset I'm now in. And so on line 7, I'm assuming that I want to assign the return value of meow to a new variable called meows, which I've annotated with this type hint as being a stir, just so we can see another variable. This one's not an int, but a stir instead. Well, let me go ahead and run this code now. Python of meows.py, enter, typing in 3, and you'll see a curious bug, meow, 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 none. Well, why is that? Well, it turns out at the moment, my meow function only has a side effect. It just prints out meow some number of times. It doesn't explicitly return a value, as it would if there were literally the return keyword there. By default, then, when a function in Python does not explicitly return a value, its implicit return value is, in effect, none. And so what we're seeing here is this. On line 8, because I'm assigning the return value of meow, which is none, to my meows variable, line 3 is what's still printing meow, meow, meow. And line 8 is what's now incorrectly printing none, because I accidentally thought that meow returns a value, but it doesn't. So its return value is effectively none. So I'm printing very weirdly the word none at the bottom. So how could I go about catching this kind of mistake too? Like, I might make this mistake, but maybe with less frequency if I'm in the habit of annotating my code with this new feature called type hints. What you can do here is this. Let me clear my terminal window to get rid of that artifact. And up here, let me additionally specify with some funny looking syntax that my meow function actually, by design, returns none. So you literally use this arrow notation in Python. When hinting what the return value of a function is, you would do this. After the parentheses, a space, a hyphen, a greater than symbol, like an arrow, and then another space, and then the type of the return value. For now, it's indeed going to return none. But now, at least, I can catch it like this. If I now run not Python, but MyPy on my code, which would be a habit I'm now getting into if using type hints, check that I'm using all of my types correctly before I even run my program, we'll see that now MyPy has found on line 7 that meow, quote unquote, does not return a value. And MyPy knows that because I have proactively annotated my meow function as having none as its return value. So now MyPy can detect that. I should now realize, oh, wait a minute, I'm being foolish here. Meow clearly does not return a value. I should not be treating it like it does on line 7. Let me go about actually fixing this now. So how do I go about fixing this? Well, let's practice what we preached in our focus on unit tests, having a function like meow not have side effects like printing itself, but let's have it return the actual string. And I can actually do this kind of cleanly. Let me clear my error message in my terminal window here. Let me get rid of the loop here. Let me say this time that, OK, fine, meow is going to return a value, an actual stir or string. So I've changed none to stir. And now I can implement this in any number of ways, maybe even using a loop. But recall that we have this syntax in Python, which will, I think, solve this problem for us. If I want to return a string of n meows, what I can actually do, recall, is this. Return, quote unquote, meow, backslash n times that number n. So it's kind of a clever one-liner, avoids the need for a for loop or something more involved than that, to just say multiply meow backslash n against itself 3 times, or n times, in this case, in general, so that I get back a big string of 0 meows, 1, 2, 3, or many more meows instead. I think now my code on line 6 is actually correct. Now I've changed meow to behave the way I was pretending to assume it always worked. So I'm storing in meows, plural, a variable that's of type stir, because now meow does have a return value of type stir itself per this type hint as well. All right, let me go ahead now and print meows. But because each of my meows comes with a trailing new line, the backslash n, I'm going to proactively fix what would be a minor aesthetic bug. And I'm just going to avoid outputting an extra new line at the end of those 3. So if I run python of meows.py now, type in 3, there's my meow, meow, meow. And now, no mention of none. Questions now on type hints and these annotations in MyPy, and using them to defensively write code that just decreases, hopefully, the probability of your own bugs.
In the return, there is a double quotes that have meow/n. Why the program don't take it as a string?
Why does the program not take it as as strange?
Sí. Yeah.
So recall that early on in the class, we looked at plus as a concatenation operator that allows you to join a string on the left and the right. Multiplication is also an overloaded operator for strings, whereby if you have a string on the left and an int on the right, it will multiply the string, so to speak, by concatenating or joining that many meows all together. So this is a feature of object-oriented programming, an operator overloading, as we saw it in the past. Other questions on type hints or MyPy?
Can we not typecast this data type of this variable number?
No, you still, and let me correct the terminology. It wouldn't be called typecasting in this context because it's not like C or C++ where there's an equivalence between these types. You're technically converting on line 5 a stir to an int. You do still have to do this because MyPy, for instance, would yell at you if you were trying to assign a stir on the right to an int on the left. You must still use the int function. Int itself is still a function. It's not a type hint. But the word int is being used in another way now in these type hints. So this int is still a function call, as it always has been. This syntax on the left is another use of the keyword int, but in the form of these type hints. So you still have to do the conversion yourself. All right, let me propose that we transition to another feature of Python that's worth knowing, especially since it's one that you'll see in the wild when you see code or libraries that other folks have written, namely something known as a docstring or document strings. It turns out in the world of Python, there is a standardized way per another PEP, Python enhancement proposal, this one 257, that essentially standardizes how you should document your functions among other aspects of your code. And so, for instance, let me go back to my meows.py file here, and let me propose that we now start documenting this code too so that I know what the meow function does. And in fact, the standard way of doing this using docstring notation would be as follows. To comment this function, not above it, as you might be in the habit of doing with code in general, but actually inside of it. But instead of commenting it like this with the usual hash comment sign, like meow n times, it turns out that when you're formally docking when you're formally documenting a function, like meow in this case, you don't use regular inline comments, so to speak. You use this syntax instead. You use triple quotation marks, either double or single. Then you write out your comment, meow n times, and then you write the same again at the end. So either 3 double quotes at the start and the end, or 3 single quotes at the start and the end. And Python has built into it certain tools and certain assumptions that if it detects that there is a comment using this docstring format, triple quotes on the left and the right, it will assume that that's indeed the documentation for that function. And it turns out in the Python ecosystem, there's a lot of tools that you can then use to analyze your code automatically, extract all of these document strings for you, and even generate web pages or PDFs of documentation for your own function. So there's these conventions via which, if you adhere to them, you can start documenting your code as for other people by generating automatically the documentation from your own code without writing something up from scratch manually. Now, it turns out if your function does take arguments and perhaps does a bit more, there are multiple conventions for how you can document for the human programmers that might be using your function, whether it's you or a colleague or someone else on the internet, to actually use these doc strings to standardize the information therein. So you might see this instead. Using these same triple quotes above and below now, you might see your one sentence explanation of the function, meow n times. Sometimes, depending on the style and use, it might actually still be on the first line, but with a blank line below it. But I'll keep everything uniformly indented. And this is a convention used by some popular Python documentation tools as well. You would say syntax like this: param n colon, and then a description of what n is, number of times to meow. Then colon type n colon int, which just indicates that the type of n is an integer. Then if this function could actually raise an exception, you can document that too. And actually, it's not really, well, it's arguably my mistake here. If n comes in as an argument and is not in fact an int, maybe it's a float or a string or something else, the multiplication sign here is not going to work. It's not going to multiply the string. It's going to trigger what I know from experience to be a type error. So I'm going to go ahead and proactively say in my own documentation that this function technically, if you use it wrong, could raise a type error, even though I'm hinting up here with this annotation that you should pass in an int. Again, Python doesn't enforce that. So if you pass in a float, this might in fact raise this function a type error. And so that might happen if n is not an int. And then lastly, I might say, for clarity's sake, for other programmers, this function returns a string of n meows, 1 per line. And the return type of that value, our type, is going to be stir. Now, all of this syntax here, as I've used it, is not Python per se. This is a convention known as restructured text, which is a form of markdown-like language that's used for documentation, for websites, for blogs, and even more. But it's one of the popular conventions within the world of Python to document your own functions. So this does not have anything to do fundamentally with type hints. Type hints are a feature of Python. What I'm doing here is just adhering to a third-party convention of putting in between a Python docstring from the start to the end a certain standard format so that these third-party tools can analyze my code for me, top to bottom, left to right, and ideally generate documentation for me. It can generate a PDF, a web page, or something else so that I or my colleagues don't need to not just only write code, but also manually create documentation for our code. We can keep everything together and use tools to generate the same for us. Any questions now on these doc strings, which again are a convention of documenting your own code, often following some standard syntax?
Yeah, so when you say like you would document it and put it in a PDF, is the purpose of doing this to kind of like publish it and share your function so other users can use it?
Absolutely. In the past, when we have installed some third-party libraries, for instance, cowse a few weeks back, recall that I showed you what functions it had. But if you read the documentation, you might actually see that it was documented for us by the author of that program. Now, I don't believe they were using this particular syntax, but it was definitely useful for you and me to be able to read some web page or PDF telling us how to use the library, rather than wasting time reading through someone else's code and trying to infer what functions exist and how to use them. It just tends to be much more developer friendly to have proper documentation for our own code or libraries as well. Other questions?
Yeah, when with docstrings, when it's used to generate like a PDF or whatever, does it include any of the code? So if you're referencing in your comment, if you're referencing the code and the comment itself might not make sense without seeing the code, do these include it?
Short answer, you can do that. Not in the convention I'm using here, but there's actually a clever way to write in your docstrings sample inputs to your functions and sample outputs for your functions. And if you use a different tool that we've not discussed, that tool will run your code using those sample inputs. It will check that your outputs match your sample outputs. And if not, the program will yell at you saying you've got a bug somewhere. So this is just another way where you can use docstrings to not only document, but even catch errors in your code. This has been a lot, and there's a bit more to go. Why don't we go ahead here and take a 5-minute break, and when we resume, we'll take a look at yet another feature of Python, yet another library to write code faster. All right, suppose we want to modify this meows program to actually take its input not from the input function in the blinking prompt, but from the command line. Recall in our discussion of libraries that you could use something like sys.argv to get at command line arguments that a human has provided when you're running your program. So why don't we whip up a version of meow that uses command line arguments instead of, again, input. So I'm going to go ahead and delete what we've done here thus far. And let me propose that we import sys, as we've done in the past. And let's do this. How about if the user does not type any command line arguments, then my program will just meow once, just so that it does something visually interesting. Otherwise, let's also give the user an option to specify how many times I want the cat to meow. So let's start simple. Let's first of all go ahead and do this. If the length of sys.argv equals 1, that is, the user only typed the name of the program and nothing else after the in their command, then let's go ahead and just print out one meow like this. Else, for now, let's go ahead and print out something like this. Else, go ahead and print out, let's say, usage for the program, which will be usage of meows.py, just so that the user knows that the program itself is called meows.py. All right, now let me go down to my terminal window and start to type Python of meows.py. And at this point, notice that the length of sys.argv should indeed be 1. Why? Well, Python, the name, doesn't end up in sys.argv at all, ever. But meows.py, the name of the file, does. And it's going to go in sys.argv 0. But that's only one element, so the length of this thing is 1. There's nothing more to the right. So when I hit enter now, we should see indeed 1 meow. If I don't cooperate, suppose I do something like meows3, enter, then I'm going to see a reminder that this is how you use the program. And this is a common convention to literally print out the word usage, a colon, then the name of the program, and maybe some explanation of how to use it. So I'm keeping it very simple. But let's be a little fancier. What if I really wanted the user to type in, maybe not 3, but something more sophisticated? And in fact, when controlling programs from the command line, it's very common to provide what are often called switches or flags, whereby you pass in something like -n, which semantically means this number of times, then often a space, and then something like the number 3. This still allows me to do other things at the command line if I want, but the fact that I've standardized on how I'm providing command line arguments to this program with -n3 is just a more reliable way now of my program knowing what does the 3 mean. It's a little less obvious. If I just do meows.py space 3, well, what does the 3 mean? At least with syntax like -n3, especially if you've read the documentation for this program, ultimately, oh, -n means number of times, got it. It's a way of passing in 2 additional arguments, but that have some relationship between them. So how do I modify my program to understand -n3? Well, if I'm using sys like this, I could do this. Elif the length of sys.argv equals this time 3. Because notice there's 1, 2, 3 things at my prompt, so sys.argv 0, 1, and 2, 3 things total separated by spaces, if it equals 3, and let's be safe, and sys.argv bracket 1 equals dash n, then let's go ahead and do this. Let's go ahead and convert sys.argv of 2 to an integer and assign it to a variable, for instance, called n. And then let's go ahead and do this. For underscore in the range of n, let's go ahead and print out some of these meows. Now, there's still an opportunity maybe to consolidate my print lines with meow, but for now, I'm going to keep these ideas separate. So I'm going to handle the default case with no arguments up here as before. And now, more interestingly, I'm going to do this to be clear. I'm going to check if the user gave me 3 command line arguments, the name of the program, dash n, and a number. If indeed the second thing they gave me in sys.argv of 1 equals dash n, then I'm going to assume that the next thing, sys.argv of 2, is going to be an integer, and I'll convert it to such and store it in this variable n. And now, just using a loop, I'm going to print out meow that many times. All right, so it's kind of a combination of our earlier focus on loops, our earlier focus on command line arguments, just creating a program that, allow me to claim, is representative of how a lot of command line programs work, even though we've typically not used many like this. But it's very common to configure a program, one, you're about to run it at the command line, with something like these command line arguments like dash n or dash something else. Now, I'm going to go ahead and hit enter. And I think I should see, indeed, 3 meows. By contrast, if I do 2 at the end, I should see 2 meows. If I do 1, I should see 1 meow. And frankly, if I just omit this altogether, I should see 1 meow as well, because that was my default case earlier. And now let me allow us to assume that this program eventually gets more complicated, right? Let's imagine a world where I don't want to support just dash n. Maybe I want to support dash a and dash b and dash c and dash d and a whole lot of others. Or heck, at that point, I should maybe give them words. So maybe it's dash dash number. It's indeed a convention in computing typically to use single dashes with a single letter, like n, but use double dashes if you're actually using a whole word like number. So the command line argument might be dash n, or maybe it's dash dash number. But you can imagine just how complicated the code gets if now you want to support dash n, dash a, dash b, dash c, and so forth. You're going to have to be checking all over the place. And what if they come in a different order? You're going to have to check, is dash n first, or is it second, or is it third, or is it fourth? I mean, this just becomes very painful very quickly just to do something relatively simple like allow the user to pass command line arguments into your program. Well, this is why, as always, there exist libraries. And another library that comes with Python that's probably worth knowing something about is this one here called argparse. In fact, with a lot of the tools I myself or CS50's team writes in Python, we very frequently use argparse whenever they are more complicated than a lot of our class demos and a little more similar to this one where we want to allow the user to pass in configuration options at the command line. And by supporting things like dash n or dash a or dash b or dash c, argparse is a library that, per its documentation, just handles all of this parsing, so to speak, this analysis of command line arguments for you automatically, so you can focus on writing the interesting parts of your program, not the command line arguments part. So how might we use this? Well, let me go back to VS Code here. Let me clear my terminal window, and let me propose that I rewrite this using not sys, but actually using argparse. And I'm going to start a little simple and then build back up. So let me throw all of this away for now and instead import argparse. Argparse stands for argument parser. To parse something means to read it, kind of pick it apart, to analyze it. So this is indeed going to do just that for me. Now let me go ahead and do this. And for this library, it's helpful to know a little object-oriented programming like we all now do. I'm going to create a variable called parser. I could call it anything I want. I'm going to set it equal to the return value of argparse dot argument parser, with a capital A and a capital P, a constructor for a class called argument parser that comes with Python itself within this library here. Now, I'm going to configure this argument parser to know about the specific command line arguments that I myself want to support in my program. So I'm going to do this, parser.add_argument. So that's apparently a method in the parser object. I'm going to add an argument of dash n Easy enough. Now I'm going to go ahead and actually parse the command line arguments. I'm going to do args, or I could call the variable anything I want, parser.parse args. And by default, parse args is going to automatically look at sys.argv for me. I don't need to import sys myself. I can leave the argument parser its code to import sys, look at sys.argv, and figure out where -n or anything else actually is. And what's nice now, because this line of code here results in the parser having parsed all of the command line arguments, I now have this object in this variable called args, inside of which are all of the values of those command line arguments, no matter what order they appeared in. Not such a big deal when I've only got one, because it's only going to go in one place at the end. But if I've got -n, -a, -b, -c, you could imagine them being in all different orders. They definitely don't have to be alphabetical. The user should be able to type them in any order they want. That's better for usability. Arg parser is going to figure all of that out for me. And all I have to do now is this. If I want to iterate over that many numbers of arguments, and that many meows, rather, I can do this. For underscore in the range of the int conversion of args.n. So dot is the syntax we kept using to access things like properties inside of an object. And that's what args is. It's an object returned by the parseArgs function for me. I'm going to go ahead now and print out, quote unquote, meow this many times. So it's not super simple. Like, these are 3 new lines of code I need to write and rather understand. But it's already a little simpler and more compact than my if and my elif and my ors and my ands and all of that Boolean logic. It's handling a lot of this for me. So if I didn't make any mistakes, let me run Python now of meows.py, enter. And I did make a mistake here. I did make a mistake. What's wrong here now? What's wrong? Well, I definitely didn't run it the way I intend. So -n3, enter. So it does work. But if I don't cooperate, this actually seems to be a worse version. If I don't pass in -n and a number, it just errors with a type error. Int must be a string. None is what came back. So there's clearly an error here. But the library is more flexible. I can actually provide some documentation on how to use this thing. So how do I know how to use this? Well, typically, it's conventional in Python and in a lot of programming environments to run a program with a special argument, -h or --help. And almost always, I will claim, you'll then see some kind of usage information. Indeed, that's what I'm looking at now. I just ran Python of meows.py space -h. I'll do it again. Let me clear my screen and this time do --help in English. Enter. And I see the same thing. It's not very useful at the moment. It just shows me what the usage is up here. And this is kind of interesting. This is a standard syntax in computing, and we've kind of seen it in Python's documentation before. This just means that the program's name is, of course, meows.py. Square brackets, as almost always in documentation, means it's optional. So I don't have to type -h, but I can. I don't have to type -n and another value, but I can. And then down here is some explanation of these options, and more verbosely showing me that I can also do --help and not just -h. But this is so generic. This has nothing to do with my program. This is not going to help my users when I actually release this software for the world. So let me go ahead and improve it. Let me add a description to my argument parser that the humans will see. Meow like a cat, quote unquote, is going to be the value of this named parameter called description. And let me also add a help parameter to my -n argument that just explains what -n means. Number of times to meow, quote unquote. I'm not going to change anything else, but I am going to go back to my terminal window and run Python of meow. I'm going to run Python of meows.py -h, or equivalently --help. And now notice that this is a little more user-friendly. If I scroll up, we still see the same usage, but there's a quick sentence in English of explanation that this program meows like a cat. And if I look at the options now, oh, that's what n means. It's the number of times to meow. And this capital N, a meta variable, if you will, is just indicating to me that I need to type a number by convention after the lowercase -n. So it would be nice, though, all that said, if my program still didn't just break when I run it without any command line arguments, right? Ideally, my program would handle this just like my manual version did when I used sys.argv myself. So we just need to add a little more functionality to this library. And if I read the documentation, I'll see that add argument takes yet another named argument if you want, you can specify a default value for -n, for instance 1, and I'll do that there. And you can further specify that it's got to be an int. And what this will additionally allow me to do is if I tell argparser to make sure that the value of -n is an int, I don't need to do the conversion manually. I can just trust down on line 7 that when I access the property called n inside of my args object, it's going to be automatically an int for me. And again, this is the value of a library. Let it do all of the work for you so you can get back to focusing on the interesting project at hand, whatever problem it is you're trying to solve. Like in this case, granted not that interesting, but meowing like a cat. Let me go ahead now and run Python of meows.py and hit enter this time. No arguments, and now it meows. Why? Because I specified that if I don't, as a user, specify -n, it's going to have a default value of 1, apparently. And I don't have to convert that value from a str to an int because I told argparser, please just make this an int for me. Any questions now on argparse, or really this principle of just outsourcing the commodity stuff, the stuff that everyone's program eventually needs to do so that you can focus on the juicy part yourself?
What does args.n contain?
What does args.n contain? It contains the integer that the human typed after a space after -n. A good question. Other questions?
Yeah, did when you specify the type for the argument, what happens if, does that basically handle the exception if the user inputs a string in this case?
A really good question. Suppose that the human does not type a number and therefore not an int. Well, let's see what happens. So Python of meows.py -n dog, where dog is obviously not a number. Enter. And voila, we see an automatically generated error message. A little cryptic, admittedly, but I'm seeing a reminder of what the usage is and a minor explanation of what is invalid about this. And again, this is what allows you, this is what allows me to like focus on writing the actual code we care about and just letting the library automate some of this stuff for us. All right. Well, allow me to propose now that we take a look at one other feature of Python that we've seen before, but it turns out we can use it even more powerfully as our programs become more sophisticated and the problems we're trying to solve themselves become more involved. Let me go ahead and return to VS Code, closing out meows.py and creating a new file, for instance, called unpack.py. So code of unpack.py. And let me just remind us like what we mean by unpacking, because this is actually a feature of Python that we've seen before. For instance, suppose that I write a program that prompts the user for their name, like David space Malin. Wouldn't it be nice if we could sort of split the user's name into 2 separate variables? And when we've done this in the past, we've done it in a few different ways, but one of them involved unpacking a single value that comes back from that, like a list or some other data structure, and putting it immediately into 2 variables. So let's do this here. Let me go ahead and call the input function, asking someone, what's your name, question mark. Then let me go ahead and just split a little naively on a single space. So I'm assuming that the only users at the moment are people like me, David space Malin, no middle names, no multiple names. It's just 1 and 2, which itself could be buggy for other users. But for now, I'm keeping it simple just to remind us that I can now unpack that return value with something like first underscore last equals the return value of input. And now I can go ahead and do something like this, like printing out with an F string, hello, comma, and then in curly braces first, if I just want to greet myself or any other user as hello, David, without the last name. And frankly, if I'm not using the last name, recall that a Python convention is just to name it underscore to make clear that you know you're not using that value. But it does need to be there because you're unpacking 2 values at once. So if I run this, it won't be all that unfamiliar. I'm just going to run now Python of unpack.py. I'll type in David Malin, which has a single space, and there we have it, hello, comma, David. Well, it turns out that there's other ways to unpack values, and there's other features that Python offers, especially when it comes to defining and using functions. And this is slightly more intermediate functionality, if you will, that's useful because you can start to write even more elegant and powerful code once you get comfortable with syntax like this. So let me go ahead and propose that we not just play with hello names anymore, but instead do something maybe involving some coinage again. So maybe not dollars and cents, but maybe again, as in the past, some galleons and sickles and knuts, among which there's a mathematical relationship as to how many of those in the wizarding world equal each other. And let me go ahead and do this. Let me define a simple function called total that just tells me the total value of someone's vault in Gringotts, the wizarding bank, based on how many galleons, sickles, and knuts that they have, which again are currencies from the wizarding world as opposed to our actual human world. So this total function might take a variable like galleons and sickles and knuts like this, and then it's going to return the formula, which I admittedly had to look up myself. And it turns out that the formula for converting galleons and sickles to knuts would be this: galleons times 17 plus sickles, then times all of that by 29, and then add in the individual knuts. Not sure in what detail this came up in the books or movies, but here we have it, the official formula. All right, now let's go ahead and do this. Let me go ahead and call the total function with just some sample inputs. Suppose that someone like Harry has 100 galleons, 50 sickles, and 25 knuts. Let me go ahead and print that out on the screen. All right, well, if total returns an integer, which I think this arithmetic expression will do, let me go ahead and pass the return value of total to print. And then just for clarity, let me write knuts at the end so I know that the unit of measure here is indeed knuts in total. All right, now let me go ahead in my terminal window and run Python of unpack.py and hit enter. And it turns out, mathematically, that if I got my math correct, 100 galleons plus 50 sickles plus 25 knuts equals in total 50,775 knuts. Just avoiding having to use our own human currency here. But I'm not doing anything along the lines of unpacking, at least just yet. Let me propose now that I do this. Just for the sake of discussion, let me propose that I leave the total function as is, but let me go ahead and just store all of my coins in a list. So coins in order from left to right, 100, 50, 25. Just because for whatever purposes in this story, I have all of my coinage in a list in this order. Kind of a purse or wallet of sorts. Well, how can I pass this in? Well, I'm not going to hard code the same values twice. Just for the sake of discussion, how could I pass in the individual elements of a list to my total function? Well, of course, I could treat this list, as I always do, using numeric indices by doing coins bracket 0, coins bracket 1, coins bracket 2. So this is old school stuff with lists. If I've got a list called coins and there's 3 elements, the indices or indexes of those elements are 0, 1, and 2, respectively, from left to right. So all I'm doing here now is passing in the first element from that list as galleons, the second element of that list as sickles, and the third element of this list as my knuts. And that lines up with, of course, the signature of this function, which, as total, expects that I've passed in those 3 things in that order, left to right. All right, let me go ahead and run, just to make sure I haven't broken anything, unpack.py and hit enter, and the math still checks out. But this is getting a little verbose, and wouldn't it be nice if I could just pass the list of coins to this total function? Wouldn't it be nice if I could just say something like this, coins? But let me pause and ask the group, why would this not actually work as is? It technically is passing in all 3, but why would I get some kind of error when I run this? Eric?
Because you are passing a list to galleons.
Yeah, I'm passing a list to galleons and nothing for sickles and knuts. And notice those don't have default values. There's no equal signs on that first line of code, which means Python's not going to know what value should be assumed there. So it just seems like it's not going to work. Plus, it's the wrong type, as Eric notes. It's a list, and it's not an integer as it was before. So let's actually run this incorrect version, Python of unpack.py, enter, type error. And that is probably what you might expect. Like I'm messing up with the types here, and I'm required to pass in 2 positional arguments, sickles and knuts, that were not even passed. So I've definitely erred here. But it certainly seems unfortunate if the only solution to this is to do what I previously did, which is index into the first element, index into the second element, index into the third. Like you can imagine, with bigger, fancier functions that take even more arguments, this is going to get very verbose and honestly very vulnerable potentially to just mistakes, typos on my part. But here, too, is where you can do what's known, again, as unpacking a value in Python. Right now, a list is kind of packed with multiple values. My current list has these 3 values, 100, 50, and 25, respectively. But they're all packed up in this one list. Wouldn't it be nice if I could unpack that list, just like I previously unpacked the return value of the stir class's split function into multiple things, too? And indeed, I can do just that. Python actually allows me to pass in not coins, but star coins. So if you use a single asterisk at the beginning of your variable, that will unpack it. And it will take one sequence, in this case, coins of size 3, and explode it, if you will, unpack it into 3 individual arguments. No commas are needed. Python just handles this for you. But the effect of passing in star coins is to pass in the individual members of that list, which in this case are going to be 100, 50, and 25 respectively, which is perfect because now it's going to line up with galleons, sickles, knuts respectively. So now when I run Python of unpack.py, we're back in business. And the math checks out, but I've kind of cleaned up my code by just introducing this new symbol, which we've used, of course, in other contexts for multiplication and the like. But now it's also used for unpacking in this way. Questions on what we've just done? It's a single operator, but it's already quite powerful because it allows us to take a data structure and unpack it and pass it in individually.
Does that work for tuples, sets, dictionaries as well?
Tuples, yes. Sets, I don't know. Rungshin, I don't know if order is preserved. No. Oh, is that no, it does not? Or you know you're checking? Order's not preserved. So it wouldn't work with set? Does not work with set. Does not work with set. Sorry, I'm verbally Googling here just to save us some keystrokes. So it would work for enumerations where order is indeed preserved. And we'll see another example in a moment where it actually can be used in a different way for dictionaries, which nowadays do preserve order. Other questions on unpacking in this way?
Yes. Hi.
Hello.
Can you use unpacking to get the value, for example, 10 plus 50 plus 25 instead of a for loop and then result plus?
Short answer, no. If you want the individual values, you should be just indexing, in this case, into those specific locations. This is returning multiple values, the equivalent of a comma-separated list. So you would use the earlier approach if you cared about the individual locations. How about one other question on unpacking?
What if we have declared, we declare some default values, and if you use this asterisk coins, will it overwrite or will it skip it?
Good question. If I heard you right, what if, for instance, the list has 4 values, like this here, and you're still unpacking it when it's only 3 that's expected? Well, let's try it. Python of unpack.py, enter. Another type error. This time it takes 3 positional arguments, but 4 were given. So the onus is on us as the programmer not to do that in this case. So potentially fragile, but avoidable if I'm controlling the contents of this list. In fact, let me propose now that we take a look at another variant of this, whereby we use not just positional arguments, whereby we trust that the first is galleons, the second is sickles, the third is knuts. Suppose that we actually passed in the names, as we're allowed to do in Python, and then technically we could pass them in any order, and Python would figure it out using named parameters instead. Well, how might I do this? Well, it's going to be a bit of a regression at first, so let me get rid of this list here. Let me change this now to just manually pass in the values I care about. Galleons, I want to still equal 100. Sickles, I want to equal 50. And knuts, I want to equal 25. So this is old school parameter passing. It's no longer positional. I'm explicitly specifying the names of these arguments. But that's just going to work because that's exactly what the names of these parameters are in my total function as before. Let's make sure I nonetheless did not break anything. Let's run Python of unpack.py, enter. And there we have it, still 50,775 knuts. Well, once you start giving things names and values, that probably should bring to mind one of our most versatile data structures in Python and even other languages, that of a dictionary. Remember that a dictionary is just a collection of key value pairs, names and their respective values. So this kind of opens up an opportunity. What if I did this? What if I actually had, for some reason in my program, on a variable as before called coins, but instead of making it a list of 3 values like before, what if it's a proper dictionary? So what if it's galleons, quote unquote, colon 100 for 100 of those, sickles, quote unquote, and 50 of those, and knuts, quote unquote, 25 of those, each of those separated by colons. And let me fix my square brackets to this time be curly braces, which recall is the symbol we use for dictionaries or dict objects in Python. So now I have a dictionary called coins, not a list. It's a collection of keys and values, 3 keys, galleons, sickles, knuts, and 3 values, 100, 50, 25 respectively. If I were to now pass these individual values into my total function, I could do it as always with my dictionary. So I'm doing it old school now. Coins is the name of my dictionary. I index into it not with numbers like with lists, but with words. So galleons, strings like this, coins, quote unquote, sickles in square brackets there. And then lastly, coins, square brackets, quote unquote, knuts. So it's verbose again. Like this is not maybe the best road to go down, but we'll backpedal in a moment. This is just how, if you happen to have all of your coins stored in a dictionary, you could pass the galleons, sickles, and knuts into your function respectively. Let's make sure I didn't break anything. Let's rerun Python of unpack.py, and we're still good. Now, how could we get to a situation like this? Well, as always, imagine this program's a little longer than this one here, and somehow you're using a dictionary, maybe just to keep track of someone's purse or wallet, like how many coins of each type that they have, and as such, it's perfectly reasonable to use a dictionary. But then you want to print out the total, and darn it, if that total function does not expect a dictionary, so you cannot just do something nice and simple like pass in coins for reasons we saw earlier. That would be a type error. Total expects 3 arguments, 3 integers. You can't just pass in a dictionary. But if that's the data structure you're using to store the person's purse or wallet, well, it's kind of unfortunate that we have this clash between these data types. Well, here's what we can do. We can't pass in coins because watch, if I try doing that and run Python of unpack.py, we're getting another type error. Missing 2 required positional arguments, sickles and knuts. I have to pass in 3 things. But wonderfully, Python allows you to unpack dictionaries as well. For a dictionary, you don't use a single asterisk, you use 2. And what this syntax has the effect of doing is passing in 3 values with names. It has the effect of passing in galleons equals 100, comma, sickles equals 50, comma, knuts equals 25. And so it has the similar effect to the list unpacking, but that just passed in the values, 100, 50, 25, separated by commas in effect. When unpacking a dictionary, it passes in the keys and the values, separated conceptually with equal signs, just like our function expects. So if I now run Python of unpack.py again, we're still good, but we've tightened our code up again. And now I'm giving myself yet another option. I can either store a wizard's purse or wallets in a list, as we did earlier, or I can store it a little more with even more specificity using a dictionary instead. And so to be clear, let me rewind. Star coins is the same thing, if I rewind a little bit, to our first example of named arguments is equivalent to what I've highlighted here. When you unpack a dictionary, it passes in all of the keys and all of the values, much like this syntax here. But let me tighten it up and go to where we left off. Questions now on unpacking.
Can we have in this dictionary, can we have, instead of having a constant name-value pair, can we have a variable number of, name-value pairs?
Short answer, yes. You can have more than 3 key-value pairs as I have here. But it's not going to work unpacking it if the total function is expecting only 3. So if I were to add something here, like let me introduce pennies to the wizarding world, and suppose I have 1 penny, for instance, and now I run this same code, Python of unpack.py, we're back to a type error again, whereby I got an unexpected keyword argument, pennies, because that is not expected by the total function. We will see in just a moment, wonderfully, a solution, though, to that. But for now, it does not work. Other questions on unpacking with dictionaries or lists?
in list values, we gave the same number of arguments and we declared a default value in the function. Now, if you use this asterisk, will it override that value or will it skip the default value?
A good question. If we did have default values up here, for instance, equals 0, equals 0, equals 0. The upside of that, recall from our discussion of arguments to functions a while back, is that now you don't have to pass in all of those values. They will default to those zeros. Therefore, you could pass in fewer than 3 values, either using a list or a dictionary that's unpacked in this scenario. I deliberately did not do that because I wanted us to encounter this specific error in this case, but you could absolutely go back and add those defaults. So it turns out that this single asterisk or this double asterisk is not only used in the context of unpacking, that same syntax is actually used as a visual indicator in Python when a function itself might very well take a variable number of arguments. That is to say, a function can be variadic, which means that it doesn't necessarily have to take, say, 3 arguments specifically. Even if they do or don't have default values, it can take maybe 0 or 1 or 2 or 3. And it turns out the syntax for implementing the same idea is quite similar in spirit. In fact, let me go back to VS Code here, and let me propose that we start over with this code and get rid of our notion of galleons and sickles and canuts and do something just a little more generic, just so that we've seen the syntax for this. Suppose that I define a function as follows. Define a function, let's call it f, and that function is not going to take a specific number of arguments, but a variable one. And so I'm going to go ahead and use this syntax here, star args, which indicates that this function is indeed variadic. It takes some variable number of positional arguments. Positional in the sense that they go typically from left to right. But I don't know how many just yet I want to support. Suppose that I additionally want to support some number of keyword arguments, that is, named parameters that can be called optionally and individually by their own name. Well, the convention syntactically here would be to use 2 stars and then kw args. I could call args or kw args anything else that I want, but a convention you'll frequently see in Python's own documentation is that when you have placeholders like this for some number of arguments and some number of keyword arguments, the world tends to use args and kw args. Well, inside of this function, let's do something super simple just for now. Let me go ahead and print out literally, quote unquote, positional, just to indicate to myself while wrapping my mind around what's going on here, what the positional arguments are. And let me quite simply print out those args. This is not something you would typically do. You don't typically just take in these arguments and print them, no matter how many there are. I'm just doing this diagnostically for now to show you how the syntax works. Now, let me go ahead at the bottom of my file, and I won't bother with the main function this time, so we can focus only on this function f. Let me go ahead and just call f with 3 arguments. I'll use the same arguments as before, but I didn't bother giving them names just yet, like galleons and sickles and canuts and the like. So what do I have? A program that no matter what calls this function f, but it first defines f at the top of the file as taking some number of positional arguments, some number of named arguments, and for the moment, I'm just printing out the positional ones. Let me go ahead and in my terminal window run python of unpack.py and hit enter. And you'll see that the positional arguments passed in are apparently this, a sequence, 100, 50, 25. But notice this. If I clear my terminal window there and pass in something else like 5, a 4th argument, previously, if I tried to change the number of arguments I'm passing in to my total function, which was only defined as taking 3, I would have gotten a type error, some visual indication that no, you can't pass in more or fewer arguments than is actually in the function's definition. But now watch. If I run python of unpack.py, this time passing in 100, 50, 25, and 5, a 4th argument, all 4 of those went through just fine. I can get rid of all of those but 1, for instance, now, rerun my program after clearing my screen, and now I'll see just 1 argument here. And even though there's a comma and nothing after it, this is actually the syntax when seeing a tuple, in effect, whereby the comma just indicates this is indeed a list, but there's only 1 element therein. Well, let's get a little more curious, too. Let me go ahead and rewind here to where we started with just those 3 values. And this time, let me go ahead and print out my named argument, so to speak, which is an args, but kw args. Again, the positional args in this syntax come first. The named arguments, kw args, come second. That's what Python prescribes. So now let me go ahead and not pass in just these numbers. Let me go ahead and pass in actually named arguments. So let me do something now, more specifically, like galleons equals 100, and sickles equals 50, and knuts equals 25. I'm not going to bother doing any math with total. I just want to poke around right now at this functionality of having a variable number of arguments. And what's neat now is if I run Python of unpack.py and hit enter, no problem. What kwargs is automatically a dictionary that contains all of the named arguments that were passed to my function. Which is to say, when designing your own functions, if you want to support more than one argument, maybe more than 2 or 3 or 4, maybe a variable number of arguments indeed, you can support both. A variable number of positional arguments that are just value, comma, value, comma, value, or any number of named arguments where you actually put the name of the parameter equals the value and then maybe a comma and some more of the same. So now it turns out we have seen this before in some of the functions we've used to date. We didn't necessarily see it called args or necessarily see it called kwargs, but we have seen at least one example of this in the wild. Recall our old friend print, which we've been using now for weeks. And when we first looked at the documentation for print way back when, it looked a little something like this. The first argument to print was objects, and I waved my hand at the time at the asterisk that was at the start of that variable name. But then we had sep for separator, the default value of which was a space. We had n, the default value of which was a new line, and then some other named arguments that we waved our hands at then and I'll again do now. But what you can now perhaps infer from our emphasis on these asterisks today, the single stars or the double stars, is that, you know what? This is the convention in Python's documentation to indicate that print takes a variable number of arguments. So if we were to look at the actual implementation of the print function implemented by Python's own authors, it might very well look something like this. Def print, and then the first argument would be star objects, thereby indicating that print takes a variable number of arguments, the next one of which might be sep equals quote unquote, either using double quotes or, as in the documentation, single quotes too. The next one of which might be n, the default value of which is a new line, and then some of those other named arguments that we've not looked at as well. And then maybe inside of the print function implemented by the authors of Python, maybe there's a for loop like for object in objects that allows them to iterate over each of those variable number of objects and print each of them. And this is why in programs past, you and I have been able to do just print, open parenthesis, close parenthesis, with nothing inside. Or you and I have been able to print out something like hello world, a single string inside of those parentheses. Or you and I have been able to do a single string hello and then another string, quote unquote, world, thereby passing in 2 arguments or even more. So we've long had this ability to use variadic functions whereby you can pass in a variable number of arguments. What you now have via this args and kwarg syntax, but again, they do not need to be called that, is the ability, using that star or 2 stars, to implement those kinds of functions yourself. My own f function a moment ago did not do anything all that interesting, but it hints at how you could, if in the future you have a use case for taking 0 or 1 or more of either type of argument. Any questions now on these types of arguments?
What will happen if you print quarks and the argument is like a list?
So what would happen if you print the argument like it's a list? So I think we saw that. If I roll back in my history here to when I had that f function, which I called f just to be very generic, just so we could play around with the syntax, this is what I had here. So this is a, I passed in 100, 50, 25. That gets automatically stored in args. And when I run it, you can actually see that sequence of values by running python of unpack.py. There is that sequence, all in the form of one single variable. I'm printing it just for diagnostic purposes. This is not really a useful or pretty program, but it hints at how we can access that whole sequence of values. Other questions on this approach here?
Can we pass kwargs from one function to another function?
Absolutely. You can pass either of those to another function, which you might want to do if you want to wrap another function, provide some additional functionality, but still pass in all of the supported arguments to the underlying function as well. All right. How about this next? It turns out that a few other tools we can add to your toolkit relate to the types of programming models that Python supports. We started out quite some time ago focusing really on procedural programming in Python, whereby we wrote code top to bottom, left to right, defining some functions, or if you will, procedures along the way, defining variables and having side effects and assigning values as needed. But we then eventually introduced, or really revealed, that Python is also very much object-oriented. And a lot of those variables, a lot of those types that we were using all that time were in fact objects that were came from certain classes. And those classes were templates of sorts, blueprints, via which you could encapsulate both data and functionality therein. Well, we also saw along the way some hints of a third paradigm of programming that Python also to some extent it supports, which is known as functional programming, whereby functions are ever more powerful in that they tend not to have side effects, no printing or changing of state globally, but rather they're completely self-contained and might take as inputs and return values. And that's generally a paradigm we saw when we started sorting things, particularly with functions like our sort function or lambda function, when we passed in the function we wanted to use to sort a list way back when. Well, it turns out Python has other functionality that is reminiscent of functional programming and indeed is a powerful way to solve problems a little more differently still. Let me propose this. Let me propose that I whip up a new program here in VS Code by closing our unpack.py and this time creating another program called yell. Suppose the goal at hand is to implement some program that allows the user to pass in input, and then it yells the response by forcing everything to uppercase. My apologies to those with headphones there. I'll modulate. So let me go ahead and run code of yell.py. And within yell.py, let's go ahead and implement a program that really does just that. Let's go ahead and define a main function up here. And let's assume for the moment that this yell function already exists and yell something like this is CS50, properly capitalized, not in all caps. Now let's go ahead and implement this yell function with def yell. It's going to take for now a single word or phrase. And let's go ahead and I'll call it phrase here. And I'm going to go ahead and just print out the phrase.upper. So phrase.upper is going to force the whole thing to uppercase. And as usual down here, if the name of this file equals quote unquote main, then let's go ahead, as always, and call main. So let's just run this. But for the most part, it should be fairly straightforward. When I run Python of yell.py, this is CS50 is yelled on the screen. All right, that's nice, but it's not great that yell only expects a single phrase. Wouldn't it be nice, like print, if I could pass in one phrase or two or three or really multiple words more generally, but as individual words themselves? So let me retool this a little bit and change yell to take in not a phrase, but how about something like a list of words, so that ultimately I can call yell like this, quote unquote this inside of a list, quote unquote this inside of a list, and quote unquote CS50 inside of a list. I'm not going to bother with type hints or annotations for now, but I'll just assume that yell has been defined now as taking a list of words as defined here. But now I want to force them all to lowercase. So I don't quite want to do something as simple as this. Like for word in words, I could, for instance, print that given word and maybe end the line with nothing right now. But I think if I do this, Python of yell.py, no, that's not right. I haven't forced anything to uppercase. So let's fix this. Well, let's go ahead and do the following. Let me go ahead and accumulate the uppercase words as follows. Let me create a variable called uppercased and initialize it to an empty list using square brackets or our more verbose list syntax. And now let me go ahead and iterate over each of those words in words. And for each of them, let's go into our uppercased list, append to it the current word's uppercase version. So this is a way of creating a new list called uppercased that is just appending to that list each of the current words in the loop, but uppercased instead. And now just let me go ahead and print out the uppercased list. This isn't quite right. Let's see what happens here. Python of yell.py. OK, it's not quite right because I don't think I want those quotes or those square brackets. What am I seeing? I'm actually printing a list. But here's where some of our unpacking syntax now can be useful. I don't have to change my approach to this problem. I can just unpack uppercase by adding a single star. And now let me go ahead and rerun Python of yell.py. And now it's actually just English. There's no remnants of Python syntax like the quotes and the commas and the square brackets. I've now unpacked this is CS50 as 3 separate arguments to print. So already now this unpacking technique would seem to be useful. Well, it's a little unfortunate that I now need to call yell, though, with a list of values in this way. This is just not the norm, or at least it's not nearly as user-friendly as something like the print function, where I can pass in 0 or 1 or 2 or 3 or any number of arguments. Why are you making me, for your yell function, pass in only a list? Well, we can do better. Let's adopt some of the new conventions we've learned, and let's go ahead and get rid of the list by removing the square brackets, and let's just pass yell 3 arguments. Now, I don't want to do something like change the definition of words to take in like word 1, word 2. Like that's not going to scale, and it's not going to handle different number of words. But we have a technique now. We can say star args, which will allow the yell function to accept any number of arguments. And just for specificity, let's not call it generically args. Let's name it something a little more self-explanatory, like star words. This just means I have a variable number of words being passed in. Now I think I've made a marginal improvement. Let me run this again. Python of yell.py. This is CS50 is in all caps, but it's just a little better, right? Because now I can treat yell just like I've long treated print. Pass in as many things as you want, and print will deal with it. Now, my yell function is just as powerful, it would seem. And better still, it also forces everything to uppercase. Well, it turns out Python comes with this function called map, whose purpose in life is to allow you to map, that is, apply some function to every element of some sequence, like a list. So for instance, if we want to force to uppercase each of the words, this is CS50 in the list of words that's been passed in, well, we essentially want to map the uppercase function to each of those values. So using map in Python, can I do just that? Let me go back here to VS Code, and let me propose now that I re-implement this as follows. I get rid of all 3 of these lines here, getting rid of that loop in particular. Let me still declare a variable called uppercased, but let me set it equal to the return value of this new function called map. Map takes 2 arguments here in this case, the name of a function that I want to map onto a sequence of values. Well, what function do I want to apply to every word that's been passed in? Well, it turns out, thanks to my knowledge now of object-oriented programming, I know that in the stir class, there is a function called upper. We've usually called it by using the name of a string variable dot upper, open paren, close paren. But if you read the documentation for the stir class, you'll see that the function is described indeed as stir.upper. I'm not using parentheses, open and close, at the end of stir.upper because I don't want to call it now. I want to pass this function to the map function so that map can somehow add those parentheses, so to speak, and call it on every one of these words. And this is what map does quite powerfully, and is an instance indeed of functional programming whereby I'm passing to this map function another function, not calling it. I'm just passing it in by a reference of sorts. And what map is going to do for me is iterate over each of those words, call stir.upper on each of those words, and return to me a brand new list containing all of those results together in one list. It completely obviates the need for me to do this more manually using that list. I'm still going to print the whole thing using star uppercase so that if I get back a list of 3 uppercase words, I'm going to unpack them and print them all out. So let's run this again. Python of yell.py, enter, and voila, it's still working. But the code now is even tighter than before. So it turns out there's another way we can solve this problem in a way that's even more Pythonic, or at least quite common, and that's using a feature known as a list comprehension. And it's a big phrase, if you will, but it refers to the ability in Python for you to very easily construct a list on the fly without using a loop, without calling append and append, but to do everything in one, dare say, elegant one-liner. So how can I go about using this notion of a list comprehension? Well, let me go ahead and do this. In yell.py, in VS Code here, let me go ahead and change my approach as follows. Instead of using map, which is perfectly fine and correct in this way, let me just show you this other way as well. A list comprehension is the opportunity to create a list like this using square brackets like this, but inside of those square brackets to write a Python expression that in effect is going to dynamically generate a brand new list for you using some logic you've written. And the approach I might take here is this. If I want to store in this list the uppercase version of every word in that words list, I can do this. Word.upper for word in words. Now, this is a mouthful, but I dare say Python programmers love this capability of being able to define on the fly a list inside of which is any number of values that you would ordinarily, at least as we've done it, construct with a loop, and again, calling append and append and append, but that usually takes 2, 3, 4 or more lines. This list comprehension that I've highlighted here is now an alternative way to create the exact same thing, a list inside of which are a whole bunch of uppercased words. Which words? For each word in the words list that was passed into Yell is what ends up in this list. Questions on this syntax here? It definitely takes a little bit of getting used to, because you've got like this value on the left, this function call here. You've got this loop inside of the square brackets. But if you become accustomed to reading the code in this way from left to right, this means give me the uppercase version of the word for each word in my words list. Questions here on list comprehensions?
Hi. Can you do conditionals also like if, else, or combine? If, else?
Indeed you can. And let me come back to that where we'll see an opportunity to do things conditionally. But for now, I'm just uppercasing every word in the list. A good question. Other questions?
Yeah. Is this functional programming, or I mean this particular thing where you're saying words.upper for word in words?
Not necessarily. This is more of a feature of Python, I would say. Okay. Yeah. Map was one very specific incarnation thereof. Our use of lambda and passing it in as a key attribute to the sorted function a while back was an example, and we're about to see one other. So we can even use these list comprehensions to filter values in or out of our resulting list. So in fact, in VS Code here, let me close yell.py and close my terminal window. And let me create a new program here whose purpose in life maybe is to take our same list of students as before with a shorter version thereof and just filter out all of the students in Gryffindor. So let me go ahead and create a file called Gryffindors.py. I'm going to go ahead and copy paste from before really my list of students, at least Hermione, Harry, Ron, and Draco from the start here, just so that I can focus on one student who happens not to be from Slytherin. And what I'm going to do here now, if I want to filter out only the Gryffindor students, let me go ahead and do this. Let me create another variable called Gryffindors, which is going to equal the following list. And this is going to be a bit of a longer line, so I'm going to proactively move my square brackets onto 2 separate lines. And I'm going to create now a list comprehension. I want to do this. I want this new list called Gryffindors to contain every student's name for each student in the students list, but if the student's house equals quote unquote Gryffindor. So this is nearly identical in spirit to what I just did earlier to create a list comprehension out of each of the words passed to my yell function. But here, I'm doing so conditionally. And so I'm borrowing inspiration from our focus on loops, borrowing some inspiration from our focus on conditionals, combining that into this same square bracket notation so that what Gryffindors ultimately is 0 or more students' names, and the names that are included are the result of iterating over each of those students and only including in the final result the students whose house happens to be Gryffindor. So when I go ahead and run this with Python of Gryffindors.py and hit enter, you'll see, nothing actually happened here. Well, that's because I didn't finish the program. Let me go ahead and actually finish the program with this. How about for each Gryffindor in Gryffindors plural, and better yet, so that it's sensible that I did all of this work in advance, let me go ahead and sort all of those names with our familiar sorted function. Let's go ahead now and print out each of these Gryffindors. So now notice, if familiar with the books and the movies, you'll know that only 3 of these 4 students are actually in Gryffindor. And if I run Python of Gryffindor.py, There we see Harry, Hermione, and Ron, but now in sorted order as well. So that's just one way we can solve this same problem using not just a list comprehension, but a list comprehension that has this conditional therein. But there's yet other ways to solve this same problem too, and we come back to some functional features of Python. In addition to functions like map, there's also this one called filter that can be used to achieve the same effect, but with a more functional approach, if you will. Let me go back to VS Code here, and with the same example, let me do this. Let me leave the original list up above as before, including Draco, who's not, in fact, from Gryffindor. And let me temporarily define a function called isGryffindor that takes in as value something like a student S. And then let's do this. Let's go ahead and say if S, quote unquote, house equals Gryffindor, then go ahead and return true. Otherwise, go ahead and return false. Now, we've seen before conditionals like this that are a bit unnecessarily verbose. I don't need to have a conditional if I'm already asking a Boolean question up here. So I can actually tighten this up as we've done in the past and just return, does the student's house equal Gryffindor? Either it does and it's true, or it doesn't and it's false. I don't need to explicitly return true or false. I can just return the value of that Boolean. Let's go ahead now and do this. I'm going to create, as before, a variable called Gryffindors, a list for all of my Gryffindor students that equals to, this time, the result of calling filter. Filter takes at least two arguments here, one of which is the name of a function to call isGryffindor, and I'm going to apply that function to each of the elements of this sequence here. So similar in spirit to map, I'm passing in a function that's going to be applied to each of the elements in the sequence. But map returns one value for each element in the sequence. That's how we forced all of the words to uppercase. But if I want to conditionally include a student in my resulting Gryffindors list, I can use filter instead. Filter expects its first function to be not something like stir.upper, but a function that returns true or false. Tell me whether or not I should include or not include the current student from the final list. And the question being asked is, do they live in Gryffindor? We're checking the dictionary's house key for that answer. And so ultimately, I think we'll be left with something quite similar. For Gryffindor in the sorted let's do for Gryffindor in Gryffindors, let's go ahead then and print out the current student's Gryffindor name. It's not going to be sorted just yet. But when I run this version here, Python of Gryffindors.py, and hit enter, we're back in business. It's unsorted, but we have Hermione, Harry, and Ron, but not Draco. And if you recall from a few weeks back, if we want to sort even a list of dictionaries, we can still do that too. I can call sorted on Gryffindors, plural, and I can pass in a key. And that key can have a anonymous function, aka a lambda function, that takes in a student as input, call it S, and then returns the value S quote unquote name if my goal is to sort by, indeed, students' own names. If I go ahead now and run Python of Gryffindors.py, I see the same list of students, but this time it's sorted. So here we've seen two approaches to this particular problem of Gryffindor students, whereby we can either use something like a list comprehension, and inside of that list comprehension do a bit of filtration, including an if conditional as I did, or we can take a more functional approach by just using this filter function, passing into it the function that I want to make these decisions for me, and then include only those for whom true is returned. Any questions on either of these two approaches?
Yeah, I just had a question that if we write the code like in the previous version where everything is stuffed into one line, if we check for the style of the code, then don't it have a problem with it? Because it's less readable.
So would a formatter like black have a problem with the style of some of this code?
The previous one where everything was stuffed into one line.
Oh, a good question. Would something like black have a problem with this code? Well, let me rewind to that version, which was using the somewhat longer list comprehension, which looked like, if we go far enough back, give me a few more undos, which looked like this ultimately. Let me go ahead and run black on Gryffindors.py, and you'll see that it reformatted ever so slightly, but I proactively fixed this myself. Had I done this and done it on just one line, but I knew that black might not like that, it would have fixed it for me. So I just proactively fixed it before writing the code myself. How about time for one other question on Gryffindors.py and this approach of using a list comprehension or filter?
Yeah, when using filter, instead of calling the function is Gryffindor, can you use it right there inside filter?
Can you use the function is Gryffindor? So you don't want to call it like this, because you don't want to call it then. You want filter to call the function for you, if that's what you mean. So I pass it in only by its name instead.
No, I meant if you can write the return as house equals Gryffindor inside filter.
Yes. Indeed. In fact, so recall that we indeed used these lambda functions way back when we wanted to pass in a quick and dirty function anonymously to allow sorted to filter by a different key of a dictionary. We can do that here. I can actually take the essence of this isGryffindor function. I can change the name of this function in my filter call to be another lambda function, passing in an argument like s and returning exactly that. I can now delete my isGryffindor function altogether. And now when I run Python of Gryffindors.py, I still get the same answer. And I've not bothered defining a function only to then use it in one and only one place. Well, let me propose, too, that we equip you with one other tool for your toolkit, namely dictionary comprehensions as well. And admittedly, the syntax is starting to get even weirder, but as you get more comfortable with all of these primitives and others, these are just tools that you can optionally, but perhaps powerfully use to solve future problems down the road. And with a dictionary comprehension, we have the ability to create on the fly a dictionary with keys and some values without having to do it sort of old school by creating an empty dictionary and creating a for loop and iterating over that loop and inserting more and more keys and values into the dictionary. We can rather do it all at once. So in fact, let me go back to VS Code here and let me propose now that I do this. Let me go ahead and initially do it the old-fashioned way here as follows. Let me go ahead and simplify and get rid of the houses altogether so that we can focus for now just on a list of students' names. I'm going to go ahead and run students. I'm going to go ahead and write students equals quote unquote Hermione, quote unquote Harry, and we'll keep it even shorter this time, quote unquote Ron. Only those three students in Gryffindor. I'm going to now proactively, as we've done in the past, give myself an empty list so that I have something to accumulate some answers to this problem in. And now I'm going to do something like this. For student in students, so I can iterate over each of them, let's go ahead and with the Gryffindors list, append to it the name of the student, so quote unquote name and then student, which is indeed their name from that list. And now let's go ahead and just put these students all in Gryffindor. I know these three students are in Gryffindor, so suppose that the problem at hand is that I want to build up a list of dictionaries that only contains the Gryffindor students. So it's sort of a step back from the previous version where I already had the names and the houses. For now, just assume that the problem is I have all of their names, but I don't yet have the student dictionaries themselves. So I'm rebuilding that same structure that I previously took for granted. Now let's go ahead and just for the sake of discussion, just print out these Gryffindors so we can see what we've built. If I run Python of Gryffindors.py in my prompt, I see a bit of a cryptic syntax, but again, look for our little hints. I've got a square bracket at the end and a square bracket at the beginning, and that indicates, as always, this is a list. I have a whole bunch of curly braces with a whole bunch of quoted keys. They happen to be single quotes by convention when using print on a dictionary, but that's just a visual indicator that that is my key, and the first value thereof is Hermione. Second key is a house. This value thereof is Gryffindor. Then there's a comma, which separates one dict object from the next. And if we look past Harry and Gryffindor, there's a second comma, which separates Harry and Gryffindor from Ron and Gryffindor as well. So in short, here is some code whereby I fairly manually built up with a for loop in an otherwise initially empty list the same data structure as before, minus Draco, just for Gryffindor students. But here's where, again, with dictionary comprehensions or really list comprehensions first, can we do this a little more succinctly? Let me clear my terminal window. Let's get rid of this initially empty list and this for loop that appends to it. And let's just do this. A Gryffindor's variable will equal the following list comprehension. Inside of that list, I want a dictionary structured with someone's name and their name, someone's house, and only for now Gryffindor. And that's it. but I want one of these dict objects here in these curly braces for each student in students. So here too, inside of my list comprehension with my square brackets, I want an object as I want a dictionary as indicated by the curly braces. I want each of those dictionaries to have two keys, name and house respectively. The values thereof are the student's name from earlier here and Gryffindor only. Which students do I want to create those dict objects from? Well, for student in students. So again, on the left, I have what I want in the final list. And on the right, I have a loop. And this time, no conditional. I want all of these students in Gryffindor as their house. Now, let's print this again. Python of Gryffindors.py and hit Enter. And now we have the exact same output. So instead of 3 lines, it's just 1. It's a little more cryptic to read at first glance, but once familiar with list comprehensions and this sort of syntax, it's just another way of solving that same problem. What if I want to change this and simplify? What if I don't want a list of dictionaries, which I now have? Again, per the square brackets, I have a list of 3 dict objects here. What if I just want one bigger dictionary inside of which is a key like Hermione, Gryffindor, Harry, Gryffindor, Ron, Gryffindor. I don't need a list. I don't need separate objects per student. I just want instead one big dictionary where the keys are the students' names and the values are their house. And I'm assuming for now no one's going to have the same first name in this world. Well, I can do this. Let me get rid of this here and not create a list comprehension, but again, this thing known as a dictionary comprehension. And the visual indicator or difference here is that instead of it being square brackets on the very outside, this time it's going to be curly braces instead. So inside of these curly braces, what do I want every key to be? I want every key to be the student's name. I want every value for now to be Gryffindor. And I want to do this for each student in students. And now things are getting really interesting. And this is another manifestation of Python, in some views, being very readable from left to right. Absolutely takes practice and comfort, but this is creating a variable called Gryffindor, which is going to be a dictionary per these curly braces. Every key is going to be the name of some student. Every value is going to be Gryffindor. What names of what students? Well, this dictionary comprehension will be constructed from the list of students one at a time. So when I print this now, the syntax will look a little different because it's not a list of dictionary objects. It's just one bigger dictionary object itself. But now printing Gryffindors gives me Hermione, Gryffindor, Harry, Gryffindor, and Ron, Gryffindor as well. Any questions now on what we've called dictionary comprehensions as well? Any questions on here? No? Well, let's introduce one other function from Python's toolkit, followed by one final feature and flourish. And then you're off on your way. Well, let's go ahead and think back to this. Recall some time ago that we had just a simple list of students as we have here, Hermione, Harry, and Ron. And for instance, way back when, we wanted to print out, for instance, their ranking from 1 to 2 to 3. Unfortunately, when you do something like this, for student in students, you can print out the student's name quite easily. Of course, if I do Python of Gryffindors.py, I get Hermione, Harry, Ron in that same order. But I don't see any numerical rank. I see no number 1, 2, or 3. So I could maybe do this with maybe a different type of for loop. Instead of this, why don't I try this? So maybe I could do for I in the range of the length of the student's list. And we've done something like this before. And then I could print out I, and I could print out the student's name by indexing into that list at location I. Well, what does this look like? If I run Python of Gryffindors.py, it's close. But, you know, these aren't programmers. They don't necessarily think of themselves as 0 indexed. Hermione probably wants to be first, not 0. So how can we fix this? Well, just a little bit of arithmetic. I could print out I plus 1, of course, and then the student's name. So if I clear my terminal window and run Python of Gryffindors.py once more, now we have this enumeration, 1, 2, 3, of each of these students. But it turns out that Python actually has had all this time another built-in function that you might now find useful. That is, namely, enumerate. And enumerate allows you to solve this kind of problem much more simply by iterating over some sequence, but finding out not each value one at a time, but both the value one at a time and the index thereof. It gives you back two answers at once. So if I go back to VS Code here now and take this approach, I don't need to do this complicated range and length and then I all over the place. I can more succinctly do this. I can say for I, comma, student, in the enumerate return value, passing in students. So this gives me back an enumeration, if you will. And now I can go about printing I plus 1 as before, and I can print out the student. So I don't need to index into the list with bracket I notation. I don't need to call range. I don't need to call length. Again, enumerate takes a sequence of values like these students, and it allows me to get back the current index, 0, 1, 2, and the current value, Hermione, Harry, Ron, respectively. So now it just tightened things up further. And indeed, that's been our theme here. Can we solve the same problems as we've been solving for weeks, but tighten things up using just more of this toolkit? Allow us to equip you with one final tool for your toolkit, namely this ability to generate values in Python from functions. This is not a problem that we've necessarily encountered before, but it turns out if you're writing a function that reads or generates lots of data, your function, your program, your computer might very well run out of memory and your program might not be able to run any further. But it turns out there's a solution to this problem that's something you might have in your back pocket, particularly if after this course you start crunching quite a few numbers and analyzing all the more data. In fact, let's go back to VS Code here, and let's go ahead and create a program that's perhaps timely at this time of day, particularly depending on your time zone. You might be feeling all the more sleepy. But here in the US, it's quite common to be lulled to sleep when you're struggling otherwise by counting sheep in your head. And typically, as depicted in cartoons, you might see in your mind's eye one sheep jumping over a fence and then two, and then 3 sheep and then 4. And then eventually you presumably get so bored counting these sheep, you actually do fall asleep. So in VS Code here, let's create a program called sleep.py that allows me to print out some number of sheep as though I'm counting them in my mind's eye. And via this program, let's do this. Let's prompt the user for a variable n, setting it equal to the integer conversion of the return value of input, asking the user, what's n, for how many sheep do they want to try counting? And then let's do a familiar for loop here, and we'll start counting from 0 as always. So we'll first have 0 sheep, then 1 sheep, then 2 sheep, and so on. For I, in the range of that value n, go ahead and print out, and I'll paste here an emoji representing a sheep times I. So the first iteration, I'll see 0 sheep. The second iteration, I'll see 1 and then 2, and then however many specified by n ultimately minus 1. All right, let's go down into my terminal window here and run Python of sleep.py, and I should see indeed, after typing in, say, 3 for my value of n, 0 sheep, then 1 sheep, then 2 sheep, and so forth. And if I make my terminal window even bigger here, we can, of course, do many more than this, typing in, for instance, 10, and you'll see that we get more and more sheep as time passes, presumably becoming all the more tedious to envision in my mind's eye. So let's now go ahead and practice what we've been preaching when it comes to the design of this program and see if and when we actually run into a problem. Let me go ahead here now and put all of this in a main function by defining main up here as always. Let me go ahead and indent all of this code here, and then let me just do this conditionally as always. If the name of this file equals quote unquote main, let's go ahead and call main. Let's make sure I didn't break anything just yet, even though functionally this should be nearly the same. And if I type in 3, I still have 0, then 1, then 2 sheep on the screen. But we've been in the habit, of course, of creating helper functions for ourselves. That is, factoring our code in a way that allows us to abstract away certain functionality, like generating some number of sheep, into separate functions so that, one, they're indeed abstracted and we no longer have to think about how they're implemented, and we can even reuse them in projects as in libraries. But we've also been in the habit, too, of now testing those functions, as with unit tests. So I probably shouldn't keep all of my logic anyway in main, and let's factor some of this out. Wouldn't it be nice if I could, for instance, just call a sheep function as by taking this line of code here, and instead of just printing it here, let's print out the return value of a new function called sheep that tells the function how many sheep to print, I in this case. Let's go down as always and create another function here called sheep. The sheep function now will take a parameter n that specifies how many sheep do you want to return. And so that we can test this as with a unit test, though we won't do that here, let me go ahead and not print the number of sheep as via a side effect, but let me go ahead and return one of those sheep times n so that the user gets back a whole string of sheep that's the appropriate number to print. So here too, functionally, I don't think we've changed anything too fundamentally. Python of sleep.py, typing 3, still gives us 0, then 1, and then 2 sheep. But now we at least have a framework for focusing on the implementation of this sheep function. But it's a little inelegant now that it's still up to the main function to do this iteration. We've seen in the past, way back in week 0, wouldn't it be nice to define a function that actually handles the process of returning the entire string that we want rather than just one row of sheep at a time? Well, I think we can do this. Why don't I go ahead and change sheep as follows? Let me go ahead here and first create a flock of sheep that's initially empty using an empty list. Then for I in the range of n, let's go ahead and append to that flock, for instance, 1 sheep times I, so that I keep adding to this list 0 sheep, then 1 sheep, then 2 sheep, then 3, and so forth. And then ultimately, I'm going to return the whole flock of sheep at once. So this is going to return the equivalent of all of those strings of sheep so that main can handle the printing thereof. So back up here in main, let's do this. How about for each sheep, I'll call it s, since sheep is both singular and plural. For s in sheep of n, which again returns to me a list of all of the sheep, the whole flock, let's just print out each sheep s one at a time. All right, so far so good here, I think. Let me go ahead and run Python of sleep.py and hit enter. What's n? 3. And that still seems to work just fine. But let me get a little creative here and see not just 3 sheep on my screen, but maybe 10 rows of sheep. And that too seems to work fine. Let me get a little more adventurous and type in maybe 100 sheep. And it's starting to look ugly, to be fair, but they're all printing out pretty fast. Let me go ahead and try again with maybe 1,000 sheep on the screen. And they flew by pretty fast. It's still pretty messy, but they're all there. We could count them all up. How about not just 1,000, but 10,000 sheep? Well, that too seems OK. It's taking like 10 times as long, and that's why you see this flickering on the screen. All of the sheep are still printing, but, it's a lot of data being printed. If I hang in there a little longer, hopefully we'll see all 10,000 sheep coming to pass. This is here in the video where we will speed up time a la a reel online. Oh my God, this is a lot of sheep. There we go. OK, and now all of my sheep have been printed. So it seems to be working just fine. Well, let me just be even more adventurous and OK, let me try my luck. Let me try like, how about 1 million sheep this time and hit enter. Something's no longer working. While we wait for a spoiler here, does anyone have any intuition for why my program suddenly stopped printing sheep? What is going wrong in this version wherein I'm generating this really big flock of sheep?
We might have run out of memory or computation power.
Yeah, so maybe we're actually pushing the limits of my Mac, my PCs, my cloud servers, memory, or CPU, the brains of the computer's capabilities, because it's just trying to generate massive, massive, massive lists of sheep. 1 million of those rows of sheep, each of which has a huge number of sheep. And it seems that my computer here is honestly just really struggling. And this is really unfortunate now, because it would seem that even though this program clearly works pretty well for 1,000 sheep, 10,000 sheep, once you cross some threshold, it just stops working altogether. Or it just takes way too long for the program to be useful anymore. But this seems a little silly, right? Because theoretically, I should absolutely be able to print all of these same sheep if I just printed 1 right away, then print 2 right away, then print 3, then 4, then 5. It seems that the essence of this problem, if I go back to my code, is that per my best practices, that I'm trying to practice what I'm preaching, it seems that the fundamental problem is that I've modularized my code by creating this helper function called sheep, whose purpose in life is to do all of the generation of sheep and then return all of them at once. Wouldn't it be better, and I can actually hear my fan turning on now even, just trying to generate these sheep, wouldn't it be better then to just print the sheep 1, 2, 3, 4 at a time? Well, we could do that, but that's really a step backwards. That rather contradicts all of the lessons learned of the past few weeks, where generally not putting everything in main is a good thing. Generally having an additional function that you can then test separately with unit tests is a good thing. Do we really need to give up all of those best practices just to print out some sheep and here fall asleep? Well, it turns out there's a solution to this problem, and namely in the form of these generators in Python. You can define a function as a generator whereby it can still generate a massive amount of data for your users, but you can have it return just a little bit of that data at a time. And you yourself can implement the code in almost the same way, but you don't have to worry about too much getting returned all at once. These two, like all features of Python, are documented in the official documentation therein, but what you'll find ultimately that it all boils down to this keyword here, yield. Up until now, when we've been making functions, we have been defining functions that return values, if at all, using the keyword return. And indeed, if we go back to our code here, that's exactly what I've been waiting for. I've been waiting to return the whole flock at once. Unfortunately, if you wait too long, and here we have it, my program was quote unquote killed. That is to say, my computer got so fed up with how much memory and CPU it was trying to use, it just said, nope, you're not going to run at all. And that's unfortunate. Now my program no longer works for large numbers of sheeps, which is not good if I'm really having trouble falling asleep some night. So how can I use yield to solve this problem instead? Well, let me do this. Instead of building up this massive list of sheep in this big list called flock, let's just do this instead. Let me go ahead and simplify this whole function as follows, whereby I iterate for I in the range of n, and then on each iteration, in the past, I might have been inclined to use return and return something like 1 sheep times I, but this won't work here, right? Because if you want 1,000,000 sheep and you start a for loop saying for I in the range of 1,000,000, you're going to return accidentally 0 sheep right away. And then this function is essentially useless. You shouldn't return a value in the middle of a loop like this, because you're not going to get to any of these subsequent iterations of the loop. It's going to iterate once, and boom, you return. But thanks to this other keyword in Python called yield, you can tell Python to effectively return just 1 value at a time from this loop. So if I go back to this version of my code here, and I say not return, but yield, this is like saying return 1 value at a time. Return 1 value at a time. Return 1 value at a time. The for loop will keep working, and I will keep counting from 0 to 1 to 2 all the way up toward 1,000,000, but each time the function is just going to hand you back a little piece of data. It's going to generate, so to speak, just a little bit of that data, not all of the data at once. And that's good, because my computer has a decent amount of RAM, certainly enough to fit 1 row of sheep. It just doesn't have enough memory to fit, apparently, 1,000,000 rows of so many sheep. So now, if I go to my terminal window and run Python of sleep.py and hit enter, what's n? 3 would still work, 0, then 1, and then 2. Let me go ahead and increase the size of this here and run Python of sleep.py. Let's try 1,000,000 as before and hit enter. And now I immediately see results. I don't think we'll wait for all of these sheep to be printed, because then we will literally all be asleep. But what you'll notice happening now is the program is not hanging, so to speak. It's not waiting and waiting and thinking and trying to generate the entire flock at once. It's just generating 1 row of sheep at a time, and it's flickering on the screen because there's so many of them, and that's all thanks to yield. It's generating a little bit of data at a time, not all at once. Any questions now on this feature called generators? Any questions at all? To add one more piece of terminology to the mix, just so you've heard it, this same feature here is returning what we'll technically now call an iterator. Yield is returning an iterator that allows your own code, your own for loop in main, to iterate over these generated values 1 at a time.
How does this yield actually works under the hood? I mean, is it using multi-threading?
you can think of the implementation as being asynchronous in this sense, whereby the function is returning a value immediately and then subsequently giving you back another one as well. Underneath the hood, what's really happening is the generator is just retaining state for you. It is not going to run the entire loop from top to bottom and then return a value. It's going to do one iteration and yield a result. And the Python for you is going to suspend the function, if you will, but remember on what iteration it was. So the next time you iterate over it, as is going to happen again and again in this for loop in main, you get back another value again and again. So yield returns indeed this thing called an iterator, and that iterator can be stepped over as in a loop, one element at a time. But the language Python handles all of that for you so that you don't need to do all of the underlying plumbing yourself. How about time for one other question on these generators and iterators as our sheep continue to fly by?
So in every iteration, the program will return the memory to the system, so the program will not crash?
Correct. On each iteration, it's only returning the one string of sheep that's appropriate for the current value of I. It is not trying to return all million rows of the same. And therefore, it uses really 1/1,000,000th the amount of memory, although that's a bit of an oversimplification. All right, as these sheep continue to fly across the screen, let me now go ahead and interrupt this, as you might have had to in the past with infinite loops in your own code. Even though this isn't infinite, it's just really long. Control-C will interrupt with your keyboard that program, giving me back control of my computer. Well, here we are at the end of CS50's introduction to programming with Python. And if today in particular of all days felt like a real escalation real quickly, realize that these are just additional, perhaps optional tools in your toolkit that you can add to all of the past lessons learned, so that as you exit from this course and tackle other courses or projects of your own, you have all the more of a mental model and all the more of a toolbox with which to solve those same problems. If we think back now just a few weeks ago, it was probably in our focus on functions and variables that you first started struggling. But now in retrospect, if you look back at those problems and those same problem sets, odds are those same problems would come all too easily to you now. Conditionals was the next step in the class, wherein we gave you the ability to ask questions and get answers and therefore do things conditionally in your code. We came full circle today, and you can see that you can now use those same kinds of conditionals now to do fancier things with list comprehensions and dictionary comprehensions and the like. Loops, of course, have been omnipresent now for weeks, including today as we built up those same structures. And of course, something can go wrong. And exceptions and exception handling was our mechanism for not only catching errors in code, but also raising your own exceptions so that if you're laying the foundation to write code for other people, as in the form of libraries, you can do that too. Libraries, of course, are things you can not only use, but now write on your own, be it a small module or whole package of code that you want to share with others around the world. And even better, can you write tests for your own code, for your libraries, for others' code as well, so that ultimately you can be all the more confident that not only your code is correct today, but if you make a change to your code tomorrow, you haven't broken anything, at least according to your tests, if they continue to pass. File I/O, though, meanwhile, was a way of now storing data not just in the computer's memory like all of these sheep, but actually storing things persistently, longer term to disk, be it in a CSV or something more like a binary file like an image. With regular expressions, you then had the ability to express patterns and actually validate data or extract data from information, all the more of a useful technique nowadays when so much of the world is trying to analyze and process data at scale, some of which might in fact be quite messy from the get-go. And then, of course, most recently, object-oriented programming, an opportunity to solve the same kinds of problems, but with a slightly different perspective, a way to encapsulate and to represent real-world entities, this time in code. And today, of course, etc., was so many other tools that you can add that didn't necessarily fall under any of those earlier umbrellas, but are useful functions and data types and techniques just to have, again, in your back pocket as yet other mechanisms for solving problems as well. Not just putting everyone to sleep, but I thought another way to end might be a little more vocally to try writing one final program together, this one using a library we've seen in the past, as well as one other. I've taken the liberty of installing a text-to-speech library on my computer here. And I'm going to go ahead perhaps and open a new file here called say.py in VS Code. And I'm going to go ahead here and first import our own friend, import cowsay. And I'm going to import this new library here, import pyttsx3, the Python text-to-speech library. And now, per its documentation, which I read in advance, I'm going to go ahead and create a variable for myself here, engine, equals pyttsx3.init to initialize that library for text-to-speech. I'm going to then ask the user, well, what do I want to hear spoken? And I might do something like this. A variable called this equals the return value of input. What's this shall be my simple question, and I'm going to keep it this time as a string. We've seen how to use cowsay. We can do cowsay.cow of this. Turns out this new library can allow me to use its own engine to say this as well. But then ultimately, I'm going to have to run the engine.run and wait, just in case it's a long phrase or sentence to be said. But that's it. In just 8 lines of code, not only am I apparently going to have a cow appear on the screen to close us out now, but also some synthesized text. Ultimately, then, we hope with this course that you've not only learned Python, that you've not only learned programming, but you've really learned how to solve problems and ultimately how to teach yourself new languages. Funny enough, I myself only learned Python just a few years ago. And even though I certainly went through some formal documentation and resources online, I mostly learned what I know now and even what I had to learn again for today by just asking lots of questions, be it of Google or friends who are more versed in this language than I. And so having that instinct, having that vocabulary by which to ask questions of others, to search for answers to questions, you absolutely now have enough of a foundation in Python and programming to go off and stand on your own. So you can certainly, and you're welcome and encouraged to go on and take other courses in Python and programming specifically, but better still, as quickly as you can, is to find some project that's personally of interest that uses Python or some other language, because at least from my own experience, I tend to learn best, and I hope you might too, by actually applying these skills, not to problems in the classroom, but really, truly, to problems in the real world. Allow me, with all that said, to look at my full screen terminal window here, run Python of say.py, crossing my fingers one final time in hopes that I've not made any mistakes or bugs. And here we go, Python of say.py, prompting me, what's this? How about we end on this note here?
This was CS50.